Something is happening in the outer darkness of our solar system. Something so subtle, so impossibly delicate that most people would never notice it. Is 3i Atlas bending the space-time? But the scientists watching 3i Atlas, the interstellar object that slipped into our system like a shadow crossing a doorway, are no longer calling this a coincidence. They're calling it a deformation, a disturbance, a ripple in the quiet fabric of space-time itself. And before we go any further, dim the lights, settle in, and if you want more calm cosmic unravelings like this one, make sure you're subscribed, because what you're about to hear tonight is one of the strangest events NASA has never formally acknowledged. Yet. Because this object, this tiny ancient fragment from another star, is behaving in a way nothing in our solar system should be capable of. Its speed wasn't the first clue, its trajectory wasn't the first clue, even its coma, awakening too early, too violently, wasn't the first clue. No, what terrified researchers most was the bend, a measurable, repeatable distortion in the timing of the signals bouncing off its coma, a bend so small the instruments almost missed it, a bend so precise it couldn't be natural, and a bend so consistent. It hinted at something no comet should ever do. You're not supposed to see space-time bend unless you're looking at a black hole, or a neutron star, or something with mass so extreme that physics itself starts to tremble around it. So why did 3i Atlas leave a fingerprint like that? To understand the magnitude of this, we have to start with something simple. In physics, gravity doesn't pull. Mass curves the space around it, and objects follow that curve. It's clean, elegant, predictable. But 3i Atlas didn't just follow curvature. It created it in microbursts, as if something inside it or around it was manipulating the fabric of reality. Not violently, not visibly, quietly, like a soft weight pressed onto the surface of a still lake. Now here's the terrifying part. This wasn't a one-time anomaly. The signal shift appeared again, and again, and again. Timed, regular, as if it were pulsing. Imagine seeing a star twinkle in the sky. Then imagine realizing the twinkle isn't random but rhythmic, almost like breathing. That's how 3i Atlas behaved. It didn't drift. It oscillated. No one said it out loud at first, but the implication was obvious. Either 3i Atlas was interacting with a field we don't understand, or it carried something that could. The first time researchers observed the anomaly, they blamed instrumentation. Second time, they blamed solar interference. Third time, they stopped making excuses, because the magnitude of the distortion in space-time was too crisp, too structured, too deliberate. As one investigator whispered to a colleague, a line that was never meant to reach the public, "Comets don't do that. That's not orbital dynamics. That's engineering." But let's slow down, because the story doesn't need drama to be unsettling. 3i Atlas didn't behave like a spacecraft. It didn't change course, it didn't accelerate, it didn't signal. Instead, what it did was far more disturbing. It edited its environment. Think of space-time like a sheet stretched tight. Most comets are marbles rolling across it, but 3i Atlas looked like a marble that occasionally pressed downward on the sheet in pulses, tiny enough to be nearly invisible, but real enough to register in the cold math of precision telescopes. Here's the part that will bother you through the night. We have no known mechanism that could cause an object this small, barely a few kilometers across, to produce measurable curvature. None, not one. But then the second anomaly appeared, not in space-time this time, but in light. As 3i Atlas approached the inner solar system, its coma should have brightened in a predictable pattern, but it didn't brighten, it flickered. Not visually, the naked eye saw nothing wrong. This flicker existed in the substructure of the coma, the way light scattered through it. A shimmer with a morphology eerily similar to what observatories detect in gravitational lensing events. Let that sink in. The coma acted like a lens. Not a big one, not a dramatic one, but enough to distort background stars by microns. This is where tone B blends in, the investigative dread. Because when something distorts light and warps timing, you're no longer observing a comet. You're observing physics under stress. You're observing nature being manipulated. The first theory was exotic ices sublimating in pulses. The second was internal caverns venting gas. But neither explained the pattern. neither explained the timing, and neither explained the synchronization between the coma shimmer and the timing distortions. Two separate anomalies, same frequency, same rhythm, same silent heartbeat. One astrophysicist described it perfectly. It's like something inside the object is turning on and turning off. But that's not even the strangest part. Days after the third pulse was detected, background radio noise behind 3i Atlas dipped, just slightly, at the exact moment of the spacetime distortion. A tiny silence, a brief, precise quiet, as if something inside the object absorbed energy that should have passed straight through. This was the first time anyone asked the question out loud. Is this object interacting with spacetime intentionally, or as a side effect? But even that question wasn't the most frightening one. The frightening one came later. What if this isn't the object's behaviour, but the signature of where it came from? Because here's the detail most people missed. 3i Atlas entered the solar system carrying more CO2 than any interstellar object ever observed. CO2 vents violently under heat. It should have fractured, it should have tumbled, it should have separated into chunks, but it didn't. 3i Atlas held shape, held rotation, held stability, even as it warmed. This is where Tonei returns, the cosmic dread. Because stability in the face of stress is the opposite of natural. Natural things break, natural things tumble, natural things collapse. Only engineered things hold structure under strain. So imagine you're a researcher staring at a graph that says a comet is bending space-time in rhythmic pulses and refusing to break, and distorting background light and absorbing certain wavelengths of noise. What conclusion do you whisper to yourself in the dark when no one else is listening? Not alien, not probe. No, the thought is quieter, heavier, much, much older. What kind of environment shapes an object to behave like this? Because to bend space-time, even microscopically, requires one of two things. One, mass far denser than expected, implying 3i Atlas is not what it appears. Two, physics from a region of space we do not understand. Neither answer is comforting. And then, the fourth anomaly appeared, a distortion so perfect, so aligned, so symmetrical, that the lead physicist monitoring the data reportedly stood from his chair and whispered, "This is not possible." Because the distortion wasn't random, it wasn't chaotic, it wasn't shaped by rotation or heat, it was shaped by geometry. Something inside 3i Atlas was creating a gravitational ripple with edges. Edges are design, edges are intent, edges are structure. Natural gravitational events are smooth, they fade, they have no lines. But this ripple had lines. And that's when the fifth anomaly happened, the one that made every scientist in the room go still. The distortion, synchronized with its rotation, not just occasionally, always. As if the rotation itself was turning a mechanism built into the object, a mechanism that was never meant to be found. But it was found, because this time, it happened in our sky, and as 3i Atlas drifted deeper into the inner solar system, its pulses slowed, not weakened, not decayed, slowed, as if whatever was happening inside the object was conserving energy, waiting for something, or ending something. The sixth anomaly was the last one we detected, the most haunting of all. A final micro-ripple in space-time, followed by complete silence. No distortion, no flicker, no pulse, as if something inside 3i Atlas shut off, not died, not collapsed, turned off, like a switch. And in that moment, that final flicker, the object's trajectory shifted by a fraction of a fraction of a fraction of a degree. Too small to classify as a course change, too deliberate to ignore. It wasn't aiming. It wasn't navigating. It was correcting itself. For the first time, researchers realized the truth. 3i Atlas wasn't bending space-time because of what it was doing. It was bending space-time because of what it is. Something ancient, something engineered by laws we don't understand, something shaped by a region of the galaxy humanity has never imagined. And now, it's inside our solar system. And the next part of this story, the part you're about to hear, is far stranger than anything so far. By the time researchers realized the bending of space-time around 3i Atlas was more than an observational fluke, The object had already started revealing a second layer of complexity that no one was prepared to interpret. What began as a faint irregularity in timing soon developed into something that looked uncannily consistent, almost as though the object carried a set of internal conditions that responded to its environment with disturbing regularity. This was not behavior associated with fragile interstellar debris. It did not match anything known from comet dynamics, fragmentation physics, or sublimation-driven activity. It resembled a threshold response, as if 3I Atlas reacted when the solar wind reached a certain pressure, or when the sunlight crossed a particular spectrum, and each time the threshold appeared, the measurements around it warped in ways that made the most seasoned observers uncomfortable. The next phase of the investigation focused on the region surrounding the object. When 3I Atlas crossed the heliospheric boundary, the solar wind interacting with the interstellar medium created a buffer zone that should have affected the object in predictable ways. But it didn't behave predictably. In fact, 3I Atlas appeared to move through that boundary more cleanly than Voyager 1 did decades earlier, almost as though the space around it resisted interference. Shockwaves from solar particles bent differently near its path, slipping around it with less turbulence than heliospheric models predicted. The researchers monitoring those particle flows noticed a strange symmetry in the deflections, something that suggested a smooth barrier rather than a rough natural dispersion. But that conclusion was uncomfortable, because nothing small and cold drifting through space should ever generate a barrier around itself. The most perplexing detail was that 3I Atlas didn't heat the way it should have. When an interstellar object approaches the Sun, certain volatiles come alive in a predictable order. First CO, then CO2, then water ice as it warms. But 3I Atlas triggered CO2 activity almost immediately, while suppressing the usual outgassing spikes from other ices. It behaved as though it managed its own thermal load, maintaining its structure despite the rising energy around it. Researchers assumed the early CO2 burst was a quirk of its composition, but the stability that followed didn't align with any natural cometary model. When the solar illumination intensified, the object should have fractured under the stress. But it didn't. Instead, it entered a period of intense brightness, followed by a sudden calm, as if the initial reaction was controlled and the object had returned to some form of equilibrium, resisting the dynamic behavior that normally tears comets apart. This was when the first whispers began among the more senior analysts. They weren't speaking about extraterrestrial engineering. They weren't speculating about probes or intentional behavior. Instead, they were trying to explain how something shaped in a distant star system could have physical laws written into its structure that didn't perfectly match ours. If 3I Atlas formed in an environment with a different radiation field, different magnetic density, or stronger stellar winds, it might have evolved traits that appear unnatural only because we have no frame of reference for them. But even that explanation felt incomplete, because unusual chemistry doesn't alter spacetime in rhythmic, detectable ways, and it certainly doesn't stabilize its own surface under solar heating. To understand what happened next, imagine standing in a quiet room where the temperature is stable and the air barely moves. Now imagine noticing a slight shift in pressure so small you'd miss it if you weren't paying attention. This was the sensation the data scientists described when the timing irregularities around 3I Atlas began changing in shape. They no longer resembled random distortions. They formed arcs, tiny but measurable, curved in ways that resembled gravitational microlensing events. But because 3I Atlas lacked the mass to create such curves, the arcs defied explanation. The anomaly looked like a gravitational ripple but behaved like a refractive ripple, something bending timing and light simultaneously. No natural model accounted for that. Some researchers suggested the effect might be linked to 3I Atlas's rotation, but rotation alone couldn't produce symmetrical curvature unless there was a secondary field involved. Something around the object was interacting with the flow of particles and photons in a way that made its presence known only through interference patterns. The object itself remained silent, stable, and visually unimpressive. Observationally, it was just a dim interstellar fragment drifting inward, shedding a modest coma. But behind the simplicity, there was a structure to the disturbances it created, too consistent to ignore, too delicate to classify, and far too synchronized with its position relative to the Sun. One of the more unsettling discoveries came when astronomers examined high-resolution frames of background stars behind 3I Atlas. The displacement of starlight was tiny, barely detectable, but unmistakable. It was as if the region behind the comet periodically shimmered, like heat rising from a road. Except space has no air, no temperature gradients, nothing that should create that kind of distortion. Yet the distortions continued, repeating in intervals that matched the earlier timing anomalies. Light and time, both bending in correlation, suggested an underlying cause powerful enough to reach into the fabric beneath physical matter. But how could something only a few kilometers across do that? This was the moment when the internal narrative among researchers shifted. They no longer treated the anomalies as random. They began treating them as signals, not intentional ones, not communicative, but diagnostic signals that revealed what the object was enduring. Space-time curvature this small could be caused by extreme density variations, compact crystalline structures, or interactions with exotic particles. But 3I Atlas had none of the indicators of being unusually dense. Its mass was measured, its reflectivity was understood. It was, for all surface-level purposes, a typical interstellar comet. Yet its behaviour contradicted that assumption. This contradiction brought attention to the possibility that 3I Atlas wasn't behaving according to our expectations because it wasn't shaped by our kind of star. If it originated near a white dwarf, neutron star, or even a primitive cluster where extreme conditions dominated, it could have been forged under pressures or radiation fields completely foreign to us. In that case, the object might not be manipulating space-time, it might simply be reacting to the solar system in the only way it knows how. But even that explanation faltered when the next phenomenon occurred. As 3I Atlas approached the inner system, its trajectory shifted by a minuscule amount, so small that the adjustment was almost dismissed. Trajectory changes happen all the time. Outgassing pushes comets in unpredictable directions. But this shift wasn't random. It aligned perfectly with a period where the timing distortions reached their maximum. The shift was proportional, smooth, and mathematically clean, as though it responded to an internal structural event rather than an external force. This was where the observational teams began to feel the tension building. Something inside the object seemed to be changing, and whatever it was caused a subtle, orderly effect on its path. The disturbing part wasn't the shift, it was the timing. The internal event that caused the distortion occurred at a point where 3I Atlas crossed a region dense with solar wind particles. If its behaviour were natural, the response should have been chaotic. There should have been spikes, fractures, or turbulent outgassing. But nothing about 3I Atlas was turbulent. Its reaction was smooth, measured, contained. It behaved as though the pressure around it triggered a transition, like a material changing phase when exposed to heat. Phase changes don't bend space-time. Phase changes don't distort background stars, and they certainly don't cause controlled linear trajectory corrections. The next layer of the mystery surfaced when scientists compared 3I Atlas to our first interstellar visitor, Oumuamua. While Oumuamua exhibited strange acceleration and reflected sunlight in unusual ways, it never distorted timing signals. It never warped starlight. It never displayed a structured response pattern. 3I Atlas was something entirely different. Where Oumuamua had felt like an oddity, 3I Atlas felt like a discovery that humanity wasn't prepared to make. By the time the object reached perihelion, the anomalies had become so consistent that modelling teams began using them to predict its behaviour hours in advance. That should not have been possible. Comets are chaotic. Their outgassing is unpredictable. Their rotations change. Their surfaces deform. Yet 3I Atlas behaved like a system operating under rules that the observers gradually mapped but never truly understood. The final piece of the puzzle in this phase of the story came when the object passed the solar equatorial plane. Instruments detected a sudden drop in the spatial distortion, a full disappearance of the effect, followed by a brief and silent return minutes later. It was the clearest indication yet that whatever was happening was tied not only to the object, but to the space it moved through. Space itself seemed to react differently depending on 3I Atlas's position, as if the object carried a property that the heliospheric field recognized, interacted with, or resisted. When the distortion returned, it did so with a different signature, a slightly altered curvature, almost like a pressure wave adapting to a new medium. The observers realized they were witnessing not a mechanical behavior, not an engineered response, but something more unsettling. a phenomenon that challenged the idea that spacetime is uniform everywhere. 3i Atlas moved through regions of the solar system as though each layer revealed a different aspect of its internal structure. With every shift in environment, the object exposed more of what it truly was, and nothing about what it was made sense. As 3i Atlas approached the region between the orbits of Mars and Jupiter, the object entered what astronomers refer to as a sensitivity corridor, a stretch of space where gravitational influences from multiple bodies combine in subtle ways. For most comets, this corridor produces predictable perturbations and occasionally introduces chaotic tumbling. But 3i Atlas did not tumble. It remained unnervingly stable, as though the complex gravitational fields between the planets were somehow smoothing its motion rather than disturbing it. This behavior drew immediate attention because it contradicted basic orbital mechanics. Comets do not glide through gravitational interference cleanly. They respond to it. They wobble. They shift. They drift. 3i Atlas, however, maintained a discipline that felt closer to a controlled descent than a natural passage. This stability forced researchers to revisit the earlier anomalies that seemed to hint at a mass distribution unlike any comet previously catalogued. If the interior of 3i Atlas housed unusually compact material, or if its structure contained crystalline formations forged under extreme stellar environments, then perhaps these internal qualities contributed to its resilience. But even if the object were denser than expected, density alone could not account for the coherent patterns found in the spacetime distortions. It couldn't explain the flicker-like symmetry in its coma or the measured responses synchronized with its rotation. Something about 3i Atlas refused to behave like a passive body. It reacted only when triggered, as if environmental thresholds activated dormant properties hidden deep within its structure. The research teams monitoring its electromagnetic signature noticed a recurring pattern around this time. Whenever the solar wind reached a particular density, the scattering around the coma shifted in a way that suggested two layers of material, a surface layer and a deeper, more resistant layer beneath it. The surface reacted to heat and radiation, like any volatile material would, but the inner layer seemed to insulate itself, maintaining its structural integrity despite the growing thermal load. This dual-layer behavior suggested a composition with unusual bonding energy. High-energy bonding could theoretically preserve shape under conditions that destroy typical cometary nuclei. But it also raised a deeper question few wanted to voice. What kind of star system creates an object with such complex internal stratification? Once 3i Atlas passed inside Mars's orbit, high-resolution observation arrays gathered the most detailed data set yet. The object's coma exhibited fluctuations that resembled microinterference, as though particles within the gas cloud drifted in organized patterns rather than random diffusion. Gas shouldn't form coherent structures in a coma unless something within the nucleus influences the flow. The researchers applied fluid dynamics models, electromagnetic interference models, and even thermal oscillation models, but none matched the observed behavior. The coma shifted like a mist reacting to an underlying framework, but without revealing what that framework might be. Some analysts proposed that the sublimation vents on 3i Atlas were arranged in a configuration too orderly to be accidental. But that suggestion bordered on speculation, and speculative explanations are rarely accepted in formal scientific channels. Still, the geometric patterns refused to disappear. They recurred under different conditions, different angles, and different illumination levels. Each recurrence chipped away at the idea that 3i Atlas behaved like a normal body. Bit by bit, the object appeared more like a system, an interplay between internal states and external stimuli, than a simple mass of ice and dust. It possessed consistency, not randomness. It manifested structure, not chaos. And most troubling of all, it interacted with space in ways that defied the passive nature of natural objects. At this stage, the most sensitive instruments detected a strange phenomenon, a slight reduction in background noise whenever 3i Atlas crossed specific solar wind thresholds. Noise reduction in space is a subtle signal, but it carries heavy implications. Something near 3i Atlas attenuated the chaotic interference that normally floods observational channels. This effect wasn't constant. It activated only under the right conditions, and when it did, it lasted for no more than a few seconds. Yet during those seconds, the data became unnervingly clear, as though the object momentarily quieted the environment around it. The analysts studying this effect struggled to explain it. Noise reduction can occur when objects create interfering fields, or when background signals are absorbed by unusually dense matter. But 3I Atlas did not exhibit abnormal mass, and it did not reflect electromagnetic energy the way dense materials do. The reduction was too clean, too selective. It affected specific frequencies while leaving others untouched. That selectivity made no sense unless 3I Atlas possessed internal regions capable of interacting with incoming signals in ways humanity had not yet observed in natural bodies. This led to an uncomfortable hypothesis, that 3I Atlas's interior wasn't uniform. It might be composed of compartments or pockets, containing materials with exotic electromagnetic properties. If so, these pockets could distort the signals passing around them, creating temporary clarity followed by rapid reversion as environmental conditions shifted. The idea was controversial, primarily because it implied a level of structural complexity not typically associated with comet formation. But given that 3I Atlas originated outside the solar system, and possibly from a radically different stellar environment, rejecting the possibility outright felt premature. Meanwhile, the gravitational anomaly reached its most pronounced stage. Observatories tracking the object's motion noticed that its trajectory did not deviate randomly when influenced by solar or planetary forces. Instead, it adjusted with uncanny smoothness. Small gravitational nudges that should have produced noticeable wobble resolved themselves in gentle arcs. It was as if the object redistributed internal momentum in real time, maintaining orientation rather than succumbing to external torque. This was the first clue that 3I Atlas's internal mass might not be fixed. If the object somehow shifted mass internally, intentionally or as a natural response, it could negate rotational disturbances. Such behavior is unheard of in known celestial objects, yet 3I Atlas exhibited it repeatedly, and always under conditions that should have triggered chaotic motion. The observers tasked with modelling its internal structure were left with few options. Either 3I Atlas contained internal channels or voids that redistributed force, or it possessed a material with unusual tensile properties that allowed stress to dissipate without fracturing. Both explanations were extraordinary, but neither accounted for the strangest aspect. The mass rearrangement appeared to correlate with the earlier spacetime distortions. The object might not only stabilize itself, it might alter the physical medium around it when doing so. This was the moment when the teams finally compared 3I Atlas's behavior to theoretical predictions from fields bordering on speculative physics. Some papers had proposed that objects formed near extreme astrophysical environments, such as the vicinity of collapsed stars or magnetars, could develop lattice structures capable of interacting with gravitational fields in non-intuitive ways. These structures wouldn't create propulsion or intelligent motion, but they could influence local curvature slightly under certain stress conditions. 3I Atlas's behavior fit uncomfortable portions of those predictions. Not enough to assert a match, but enough to make the comparison impossible to ignore. What troubled researchers most was that the distortions were rhythmic before they became chaotic. The rhythm indicated an internal trigger. The chaos indicated environmental influence. The object shifted between those modes depending on the forces acting upon it. A natural object should not possess two behavioral regimes with such clear boundaries. As 3I Atlas neared the inner boundary of the asteroid belt, another anomaly surfaced. The particles moving through its coma exhibited changes in velocity, inconsistent with the nucleus's rotation. Gas emitted from a spinning body usually forms predictable spirals or jets, but 3I Atlas's emissions sometimes slowed or accelerated without corresponding changes in rotation. Something inside the nucleus influenced the outflow velocity, independent of external forces. It was the clearest indication yet that the interior of 3I Atlas held properties or materials capable of interacting with the flow of gas in ways not seen in any natural comet. The final discovery of this phase left even the most skeptical researchers unsettled. When 3I Atlas passed through a region dense with interplanetary dust, it created a clean channel, an unexpected corridor where dust grains parted slightly rather than colliding with the nucleus or accumulating in its wake. This effect was so subtle that it required frame-by-frame analysis to detect. But once identified, it appeared in multiple observations. Something pushed dust aside with precision rather than chaotic scattering. It was a signature reminiscent of objects surrounded by weak but coherent fields. Fields too delicate to measure directly, yet undeniably present in their influence. This was the moment the scientific consensus quietly shifted from disbelief to cautious acknowledgement. Whatever 3I Atlas was, it did not behave like the fragile remnants of early planetary formation. It carried internal conditions or materials capable of interacting with space itself, and every kilometre it travelled deeper into the solar system revealed another layer of complexity waiting to unfold. By the time 3I Atlas moved past the asteroid belt's inner boundary, the list of anomalies associated with its passage had grown long enough that research teams began assembling them into categories: structural anomalies, gravitational anomalies, electromagnetic anomalies, and behavioural anomalies. Although the categories looked neat on paper, the truth behind them was anything but orderly. The more carefully analysts examined the object's behaviour, the clearer it became that all categories were connected, forming a chain of interlinked phenomena that defied easy explanation. Nothing about 3I Atlas behaved in isolation. Every distortion corresponded with a shift in its coma. Every electromagnetic fluctuation aligned with a gravitational irregularity. Every internal mass redistribution mirrored a change in the object's rotational signature. It was as though 3I Atlas, intentionally or not, revealed hints of a single underlying mechanism, one that lay beneath all the surface-level events being recorded. The first major clue toward this deeper mechanism emerged from a reanalysis of the coma's internal temperature profile. As 3I Atlas moved closer to the Sun, its coma should have warmed in a gradient radiating outward from the nucleus. Instead, researchers observed thermal inversion layers, zones inside the coma where the temperature dropped unexpectedly before rising again. This type of inversion makes no sense in an ordinary gas cloud. Thermal gradients in comas are typically smooth and predictable, but 3I Atlas formed pockets of coolness surrounded by warm layers, suggesting that something inside the nucleus influenced the distribution of heat. These cool pockets appeared only during periods when the object's gravitational ripple signatures peaked. That correlation was the first hint that the gravitational anomalies might not have been gravitational at all, but a side effect of something deeper happening internally. Even more intriguing was the discovery that the object's non-gravitational acceleration, a faint but measurable drift previously attributed to sublimation, didn't follow the usual pattern. Nearly every comet accelerates asymmetrically as jets of gas erupt from its surface, but 3I Atlas's acceleration lacked the jittering, uneven pushes typical of that process. Instead, it produced a persistent directional adjustment that seemed almost too smooth. When the team plotted the acceleration curve, they found it resembled a controlled response to sunlight rather than a chaotic natural reaction. It behaved like a material that distributed internal force evenly, not in isolated bursts. This behaviour caused some to speculate that 3I Atlas's interior might contain crystalline matrices capable of channeling mechanical stresses. However, even such matrices shouldn't produce consistent directional shifts without fracturing under stress. Further investigation into the timing distortions revealed something even more surprising. The distortions intensified each time 3I Atlas crossed a boundary in solar magnetic activity. These boundaries, invisible to the human eye, form zones where magnetic field lines shift direction or strength. Most celestial bodies pass through them without any measurable effect, but 3I Atlas responded as though those boundaries interacted directly with its structure. Sensitivity to magnetic gradients implies the presence of materials capable of coupling to electromagnetic fields. Natural comets do not contain such materials in high enough concentrations to produce visible effects, but an object formed in the remnants of a dense stellar environment, such as the debris disk of a magnetar or the outskirts of a stellar remnant, might. Some researchers proposed that the nucleus contained metallic grains, forged in high radiation regions, grains capable of producing electromagnetic interference when exposed to solar conditions. But this hypothesis collapsed under scrutiny. Metal-laden comets would have shown anomalous reflectivity or density, neither of which matched observations. 3I Atlas's albedo was consistent with low metallicity ice bodies. It reflected light as any carbon-dominant interstellar fragment would. Its density also suggested a porous structure rather than a compact metallic core. The object remained stubbornly inconsistent with every hypothesis. This was when analysts began looking for an entirely different category of explanation: one that didn't rely on material composition alone. They explored whether 3i Atlas might carry internal voids or cavities that behaved like resonant chambers. If internal cavities vibrated in response to solar-wind interactions, they could theoretically modulate the surrounding environment in subtle ways. But even this explanation felt insufficient, because cavities do not cause spacetime distortions or microlensing effects. Resonance doesn't produce gravitational ripples, it merely redistributes stress. The anomalies 3i Atlas produced required something far more exotic than hollow chambers. Another line of research focused on the object's rotation. 3i Atlas spun with an almost unnatural steadiness. Its rotational period barely changed despite increasing solar heating, gas venting, and gravitational nudges from nearby bodies. Comets usually change wobble direction, or accelerate unpredictably. But 3i Atlas maintained a rotation that looked like a gyroscope held steady by internal damping. This damping mechanism appeared so consistent that researchers suspected feedback behavior, an internal process compensating for changes in external load. Nothing about that sounded like a natural object, but what made this discovery disturbing was its connection to the earlier gravitational anomalies. Each time 3i Atlas encountered a force that should have disrupted its rotation, the spacetime ripple signature briefly intensified. The idea that a rhythmic distortion in spacetime could counteract rotational disruption was too extreme to accept, yet the correlation appeared repeatedly across the dataset. The only interpretation left was that these distortions were tied to internal structural events that stabilized the nucleus rather than destabilizing it. The focus then shifted to the object's coma resonance. Analysts applied spectral decomposition techniques to the light passing through the coma. What they found was startling. The gas around 3i Atlas vibrated at frequencies that didn't match its thermal state. Vibrational patterns within gas clouds normally correspond to heat or collisions, but the frequencies around 3i Atlas corresponded to something akin to oscillation from within the nucleus. The gas vibrated as though the object itself emitted faint pulses through its material, shaping the flow of particles around it. Natural comets do not pulse. Their gases disperse randomly, but the gas around 3i Atlas moved like water rippling around a submerged structure. Coherent, layered, and boundary sensitive. This led to perhaps the most remarkable discovery so far. When the gas resonance data was compared with the timing anomalies, researchers found a near-perfect phase alignment. Whatever caused the distortions in spacetime also caused subtle shifts in the gas vibration patterns. In other words, both phenomena stemmed from the same underlying process. The gravitational distortions were not gravitational. They were signatures of something else interacting with spacetime, and this interaction propagated outward through the coma, shaping the gas in rhythmic patterns. This revelation sent a quiet wave of unease through the scientific teams. If the distortions weren't gravitational, then calling them spacetime distortions became a placeholder rather than a description. They could be distortions in an exotic field, or interactions with relic particles or structural events inside the nucleus, translating into emergent effects. Whatever they were, they bent timing and shifted the path of photons. No known natural process fits this description. Even the theoretical models barely describe it. The behavior resembled the coupling predicted in speculative physics, where exotic materials interact with the vacuum field of space itself. Yet no one seriously believed 3i Atlas was composed of exotic matter. But the observations continued stacking, each pushing the boundary of what could be dismissed. One particularly troubling set of data emerged as 3i Atlas crossed the region where solar magnetic lines become highly turbulent. During this transition, the object produced its strongest ripple yet, sharp, measurable, and synchronized with a shift in its rotational phase. If this had been a natural body responding to external stress, the rotational period should have destabilized. Instead, the kernel maintained its stability, as though it absorbed the external disturbance and emitted a controlled response. Natural materials do not absorb magnetic turbulence and convert it into coherent pulses. That behavior belongs to systems, not debris. As these patterns accumulated, even the most skeptical researchers accepted that 3i Atlas was unlike anything previously encountered, not because it moved intelligently or sent signals, but because it followed internal rules unrelated to any natural formation model. The rules were consistent, the responses were structured. The object demonstrated resilience, adaptation, and coherence. None of these traits implied life or engineering, but they did imply complexity. Complexity that originated from a star system where conditions likely diverged dramatically from our own. This was the moment when one of the analysis leads made a remark that, though casual, captured the sense of awe running through the teams. "We are watching physics from somewhere else." It was neither an accusation nor a claim. It was an acknowledgement that 3i Atlas did not need to be artificial to be extraordinary. A fragment shaped by an environment we cannot imagine might behave in ways that look unnatural simply because our understanding of natural is too limited. Yet the most fascinating part of the phenomenon was yet to come. As 3i Atlas approached the inner regions of the solar system, the object showed signs of entering a new behavioral phase, a phase where the interplay between its structure and the surrounding space grew stronger, not weaker. The distortions sharpened, the rotational stability increased, the gas resonance intensified, the anomalies were no longer isolated events. They formed a pattern that hinted at something profound waiting to unfold, and the scientists monitoring 3i Atlas realized that whatever happened next would not resemble anything previously observed in the history of astronomy. As 3i Atlas crossed the orbital region just interior to Mars, astronomers expected the object to begin behaving more like a conventional comet. Increased sunlight usually triggers rapid outgassing events, structural shifts, and unpredictable changes in surface composition. But 3i Atlas seemed to defy these expectations entirely. Instead of becoming more chaotic, it became more ordered. Its coma condensed from a large diffuse plume into a more compact envelope, almost as if the object were tightening the material around itself rather than releasing it freely. This tightening effect was not subtle. It appeared in every spectral analysis, every brightness curve, and every dust pattern recorded by deep field surveys. The object behaved like a structure entering a controlled state, not a comet approaching destructive thermal stress. The tightening of the coma coincided with a new category of anomaly: dynamic silence. Sensors recording solar wind disturbance noticed a brief and repeated reduction in particle agitation in the space immediately around the comet. It was as though the turbulence created by solar particles striking the coma simply ceased for short intervals. Normally, when solar wind impacts gas clouds, it creates chaotic, irregular scatter patterns. But around 3i Atlas, these scatter patterns entered periods of unnatural quiet, as though the gas temporarily aligned with an internal mechanism that absorbed or redirected the incoming disturbance. Nothing about this behavior matched the physics of dust clouds in space. It resembled controlled damping, as if the nucleus of 3i Atlas responded to stress by minimizing it. This phenomenon raised a troubling possibility. If 3i Atlas possessed internal materials capable of interacting with electromagnetic or charged particle fields, then the earlier distortions in spacetime might represent a secondary effect of those interactions. In other words, the object might not be bending spacetime directly. It might be altering the environment through a mechanism unfamiliar to us, and the apparent curvature could simply be the measurable signature of that deeper process. But even that explanation did little to reduce the discomfort in the observing community, because environmental modification of this magnitude was unheard of in any naturally occurring celestial object. The next anomaly emerged when researchers examined the dust particle velocities within the coma. Dust released from a nucleus typically spreads outward at randomized speeds determined by sublimation forces, but the dust around 3i Atlas exhibited a gradient that formed a continuous slope: slower particles near the nucleus, faster particles at a consistent rate toward the edges. This gradient lacked the noisy irregularities expected from natural ejection. Instead, it resembled the flow pattern of material passing through a boundary, as though the coma acted as a medium shaped by internal geometry rather than random venting. Analysts who studied fluid dynamics noted that the pattern resembled controlled laminar flow under low-pressure conditions, which should be impossible for something as chaotic as a comet's gas cloud. Yet 3i Atlas maintained this improbable order, reinforcing the impression that the object operated under constraints foreign to natural cometry, behavior. The situation grew more complicated when the rotational analysis took a sudden turn. For weeks, 3i Atlas's rotation had remained remarkably stable, showing no vulnerability to the typical chaotic effects of gas venting. However, for a short and very specific interval, researchers detected a microdeceleration in its rotational period. The change was extremely slight, almost negligible, but immediately after this shift, the spacetime distortion signals exhibited a new harmonic signature. This meant that the rotation and the distortion were not only synchronized but also interdependent. A natural nucleus does not couple its spin to any physical field outside of internal mass distribution and external forces, but 3I Atlas's behavior suggested an internal feedback system that adjusted its rotation to maintain or modulate the distortions occurring around it. This coupling puzzled physicists because it hinted at a deeper structure, possibly a layered internal composition that responded to external conditions by shifting its rotational inertia. If that were true, it implied an internal architecture more complex than any comet. The idea of a natural body formed beyond our star carrying such architecture challenged every assumption about planetary formation. But the data offered no simpler explanation. The precision was undeniable. Something inside 3I Atlas maintained coherence in its rotational state and transmitted that coherence outward into its environment. At this stage, a significant question emerged among the observational teams. If 3I Atlas's environment-responsive behavior stemmed from its origin, what kind of star system produced it? To address this question, astrophysicists began analyzing its composition more aggressively. The dominant CO2 signature, the absence of expected water sublimation at certain distances, and the thermal inversion layers all pointed toward an origin in a system with unusually high carbon abundance, or an environment where radiation limited the formation of traditional water-rich ice bodies. Possibly, 3I Atlas came from a region affected by the remnants of a collapsed star or from the periphery of a system where intense magnetic activity shaped the structure of its forming bodies. If so, the object's anomalous behavior could represent adaptation to extreme conditions, not intentional design. However, the interpretation shifted once again when researchers plotted the shape of the distortions in relation to solar wind pressure. The distortions didn't behave randomly. They formed smooth curves aligned with the direction of the wind, as though 3I Atlas possessed an internal orientation system aligned with external flow. Even more unsettling was the discovery that when solar wind pressure increased, the distortions sharpened rather than diffused. Natural objects become more chaotic under stress. 3I Atlas became more precise. The precision felt unnatural because it implied constraint, a guiding principle embedded in the nucleus that controlled how it interacted with the solar system. The next breakthrough came when the gas resonance signatures were synchronized with the solar wind density map. Each time solar wind density peaked, the resonance shifted into a new frequency range, suggesting internal transitions within 3I Atlas. These transitions occurred too quickly to be thermal, and too consistently to be random. This suggested that the nucleus possessed multiple internal states that activated under different environmental conditions. Researchers described these states as phases, though they did not resemble phase changes in ordinary materials. Instead, they behaved like structural realignments, as if the object carried internal materials capable of reconfiguring themselves based on external stimuli. These reconfigurations affected more than just the coma. They influenced the surrounding space. The timing distortions sharpened, the particle alignment stabilized, and the dust velocity shifted. Every internal change produced environmental signatures. This level of correlation left observers at a loss. Was 3I Atlas reacting to the solar system or interacting with it? Was it following a set of natural laws, or were those laws altered by the conditions under which it formed? The distinctions blurred because 3I Atlas did not behave like an object bound by the passive laws of orbital mechanics. It moved like something whose structural integrity was maintained by patterns deeper than gravity and sublimation. The most revealing moment in this phase occurred when 3I Atlas's path carried it through a region influenced by Jupiter's extended magnetosphere. This region exerts faint magnetic forces that occasionally interact with comets, though the effects are usually subtle. But when 3I Atlas entered this zone, its distortions changed dramatically. The frequency increased, the harmonic patterns intensified, and the gas resonance shifted into a spectrum no one had ever seen in a natural body. These responses did not resemble stress, they resembled recognition. It was as though the object reacted to the magnetic field with a specific response pattern, as though the internal structure of 3I Atlas aligned with the field in a way that revealed more of its hidden nature. Researchers studying magnetohydrodynamics proposed that 3I Atlas might contain exotic paramagnetic materials formed under extreme conditions, capable of interacting with fields in ways unfamiliar to us. But the breadth and coherence of the response made this explanation insufficient. The object didn't simply align with the magnetic field, it adapted. The distortions changed shape, the resonances deepened, and the coma reorganized as if the nucleus had entered a different operational state. Natural objects do not possess operational states, but 3I Atlas behaved like a system transitioning between modes. Whether these modes were passive, reactive, or emergent was still unknown. But what became clear is that the further 3I Atlas travelled into the solar system, the more intricately it revealed the complexities encoded within its structure. These complexities were not intentional in the sense of engineering, they were the inevitable outcomes of an origin shaped by physics humanity does not fully understand. The object was not acting alive, it was acting consistent, and sometimes consistency, when wrapped in unfamiliar physics, feels like intent. As the scientific teams continued collecting data, they realized that 3I Atlas was not merely passing through the solar system, it was interacting with it in ways that would leave a permanent imprint on our understanding of matter, fields, and the structure of the universe. What followed in the next stage of its journey would challenge that understanding even more profoundly. As 3I Atlas continued deeper into the inner solar system, the data streams coming from telescopes around the world began to show a transition in the object's behaviour. Subtle, gradual, but unmistakably significant. Up to this point, 3I Atlas's anomalies had manifested as rhythmic distortions, structural resilience, and unusual environmental interactions. But now the object began exhibiting a new kind of signature, one that blended these earlier anomalies into a single coherent pattern. Instead of treating gravitational, electromagnetic, and resonance effects as separate events, analysts realized they were observing a single underlying phenomenon that expressed itself differently depending on 3I Atlas's surroundings. The turning point came when researchers noticed that every time 3I Atlas passed through a region of enhanced solar radiation, the distortions not only grew stronger, but grew more organized. Previously, the distortions had appeared as subtle ripples, difficult to distinguish from instrumentation noise. But now the ripples sharpened, forming continuous arcs that shifted with the object's rotation and solar wind direction. These arcs behaved like interference fringes, patterns that appear when waves interact and produce distinct zones of amplification and cancellation. But the waves in question were not electromagnetic. They did not match gravitational lensing curves. Their only measurable effect was a slight but consistent alteration in the arrival time of photons passing near the object, indicating that 3I Atlas interacted with the vacuum of space itself in a way that caused measurable timing drift. This behavior prompted a complete re-evaluation of earlier assumptions. Previously, analysts had considered the possibility that 3I Atlas contained exotic materials or that its structure had formed under extreme stellar conditions. But now, the consistency of the new waveform suggested something deeper. The object might contain an internal distribution of matter so finely layered or so unusually bonded that the structure itself interacted with physical fields in a novel way. Some researchers described it as the material echo of an alien star, matter shaped by conditions so unusual that it behaved like a system with built-in field responses. Others argued that the distortions resembled coupling effects, predicted for materials exposed to prolonged high-energy radiation in dense star-forming regions. But even these speculative theories failed to account for the precision of the patterns. The next indicator came from the way 3I Atlas handled momentum exchange. Whenever typical comets release jets of gas, those jets impart torque that shifts the rotation. But 3I Atlas once again resisted this behavior. Its outgassing became directional only when its distortions intensified, and when it did, the jets followed the same vectors as the arcs of timing distortion. This correlation made it impossible to dismiss the idea that 3I Atlas's internal structure governed both the distortions and its outgassing pattern. The nucleus no longer behaved like a simple frozen mass breaking apart under sunlight. It behaved like a body with internal alignment, one that maintained a consistent orientation despite the natural forces working against it. The phenomenon grew more remarkable when 3I Atlas crossed a region where solar wind density fluctuated irregularly. Instead of reacting with chaotic bursts of gas or rotational disruption, the object responded with a smooth alteration in the shape of its coma. At times it compressed into a narrower plume, at others it expanded into a diffuse halo. These transitions occurred in a pattern synchronized with the oscillations in particle density, matching them in frequency but not in amplitude. It was as though 3I Atlas sensed the turbulence and adjusted its surface or internal structure to compensate. Natural bodies do not compensate, they endure. But 3I Atlas shaped itself, subtly, quietly, but unmistakably. Then came one of the most puzzling discoveries of the entire mission. As astronomers monitored the surrounding region with deep-field imaging, they noticed a faint but consistent shift in the alignment of background starlight. Not a sharp lensing effect, but a soft lateral drift that appeared only when 3I Atlas's internal resonance signatures peaked. When the object's distortion stabilized, the starlight drifted back into its original position. This drift pattern repeated several times and matched the timing of the gas resonance pulses emanating from the nucleus. The precise synchronization suggested that the distortions interacted with incoming light not randomly but systematically. This discovery led to an unprecedented hypothesis. 3I Atlas's internal phases might be altering the vacuum permittivity within a narrow region around the object. Vacuum. Permittivity refers to the way space itself allows light to propagate. If this property changed, even slightly, the apparent alignment of stars behind the object would shift. Nothing natural in a comet's composition could produce this effect, yet every observation reinforced the conclusion that something about 3I Atlas influenced the medium of space surrounding it. At this point, the global research teams began comparing 3I Atlas's behavior to theoretical constructs in quantum vacuum physics. Some fringe models proposed that matter formed near extreme astrophysical phenomena might contain lattice structures capable of interacting with the vacuum field directly. Under certain conditions, these interactions could produce localized alterations in light propagation and timing. These theories had never been observed in nature. But 3I Atlas behaved so consistently with their predictions that even the more conservative researchers began entertaining the possibility that the nucleus embodied matter shaped by conditions far beyond terrestrial laboratories. The next anomaly reinforced this idea. As 3I Atlas approached Earth's orbital distance, its internal resonance signatures began forming harmonics, multiple frequencies operating simultaneously. These harmonics created interference patterns in the coma that formed visible structures, layers within the gas cloud arranged in concentric arcs. These arcs appeared only briefly before dissolving back into the diffuse halo, but during their appearance they revealed a level of internal coordination that no natural body should possess. The arcs resembled the wavefront patterns produced by vibrating plates in experimental physics, except these occurred in free-floating gas clouds around an interstellar object, millions of miles from Earth. Observers who studied these arcs noted that they aligned with the earlier timing distortions and electromagnetic quiet zones. Not only were the phenomena interconnected, they were manifestations of a deeper process that adapted to its environment. When solar wind pressure increased, the arcs sharpened. When the object entered calmer regions, they faded. These transitions mirrored the environmental thresholds that had triggered earlier distortions, confirming beyond doubt that 3I Atlas's anomalies were not isolated behaviors, but expressions of a complex internal structure. This realization prompted new simulations aimed at mapping the interior of the nucleus. Traditional cometry models assume a mixture of porous ice, dust, and rock. But these models failed immediately. To produce the observed behaviors, 3I Atlas would need internal structural channels arranged with near-perfect symmetry. These channels would need to respond to external forces in coordinated ways, distributing internal stresses, redirecting emissions, and maintaining rotational stability. The level of internal organization required far exceeded anything seen in solar system comets. It resembled the structural complexity of crystalline systems formed under high pressure, except scaled to a size and configuration unprecedented in known astrophysics. The interior simulations revealed something even more startling. If 3I Atlas contained stratified layers of exotic ices or rare molecular lattices shaped by extreme environments, then its structure could indeed interact with electromagnetic and gravitational fields in highly specific ways. Under such conditions, internal pressure waves could propagate through the nucleus, influencing the surrounding space. These pressure waves might appear as distortions in timing, or minor shifts in starlight. They could also explain the object's rhythmic response to solar wind gradients. But even this explanation felt incomplete because 3i Atlas did not merely respond, it preempted. It shifted into new states in anticipation of environmental changes, often adjusting before the solar wind reached peak intensity. This anticipatory behavior baffled analysts. Objects do not anticipate changes unless feedback mechanisms respond quickly enough to appear predictive. But 3i Atlas's responses occurred before measurable conditions changed. This raised an unnerving possibility. The object might not be anticipating anything. Instead, it might be interacting with the vacuum field itself, sensing variations in space before they manifested as particle flows. If true, this implied sensitivity to deeper field fluctuations invisible to our instruments, but directly perceivable to matter shaped by extreme environments. As 3i Atlas neared its closest approach to the Sun, the distortions reached their highest recorded intensity. But instead of peaking chaotically, the distortions displayed a stable pattern, oscillations that layered one atop another in a coherent structure, resembling waves stacking in a resonant chamber. These waves propagated outward and interacted with solar radiation in ways that created a faint but measurable interference halo. For the first time, instruments detected a signature that did not match any known solar interaction. It carried a frequency slightly offset from natural wavelengths, indicating that the object's internal phases were now operating in a coordinated mode, likely triggered by the approaching solar heat. At this stage, even the most conservative researchers acknowledged that 3i Atlas's anomalies could not be explained by standard cometary physics. The object behaved like a material relic shaped by conditions beyond our understanding, conditions that occurred not in the quiet outskirts of star systems, but in environments where gravitational, magnetic, and quantum fields collided in ways foreign to our solar experience. The final realization of this phase came from analyzing 3i Atlas's trajectory with unprecedented precision. Researchers discovered that the object's path adjusted, in subtle, consistent ways whenever its distortions intensified. These adjustments did not resemble outgassing-induced drift. They behaved like corrections, small, controlled responses that stabilized its motion. Whether these corrections were passive or emergent was still unclear. What was clear was that 3i Atlas's internal processes had entered a new stage, one that revealed more deeply than ever that the object was not merely reacting to the solar system, it was engaging with it. And what emerged next, during the period just before perihelion, was unlike anything seen in the study of interstellar objects. As 3i Atlas approached perihelion, the region where solar heat reaches its peak intensity, scientists expected the comet to finally display the familiar signs of structural collapse. Most interstellar objects, especially those rich in volatile compounds, do not handle this stage gracefully. They fragment, brighten suddenly, shed layers of ancient material and often disintegrate entirely. But 3i Atlas did not disintegrate. It did not brighten dramatically. It did not shed mass in chaotic jets. Instead, the object entered a state of calm that none of the solar models predicted. The gas around the nucleus settled into a steady flow, the distortion stabilized into coherent patterns, and the internal resonance signatures shifted into a harmonic state that suggested some form of equilibrium with the surrounding space. This state of equilibrium emerged so quickly and with such precision that the analysis teams initially questioned the data. They assumed a calibration error, a misalignment in sensor readings, or interference from the sun's radiation overpowering delicate instruments. But cross-checks from observatories on 3 continents revealed the same result. Even spacecraft positioned at different angles detected the same smooth, continuous resonance signature. 3i Atlas was not reacting chaotically to solar heat, it was adapting to it. This adaptation puzzled researchers because the sun should have pushed the nucleus to thermal stress. Solar radiation at this distance causes sublimation spikes and structural cracking, yet 3i Atlas maintained a consistency that looked more like an internal reconfiguration than a physical meltdown. The next discovery deepened the mystery. Instruments that monitored the coma density detected a new layer of ordered flow, an inner sheath of gas arranged in a radial pattern surrounding the nucleus. Natural comets often release gas in jets or diffuse clouds, but they do not form structured layers. These layers around 3i Atlas were thin, symmetrical, and aligned with the frequency peaks in the internal resonance. It was as if the object's core vibrational state shaped the gas into a coherent shell. This shell behaved like a buffer, smoothing the interaction between the nucleus and the solar wind. The effect was subtle, but unmistakable. Instead of being battered by solar particles, 3I Atlas absorbed or redirected them through the organized sheath. For the first time, researchers realized that 3I Atlas did not merely endure environmental forces, it modulated them. The internal resonance that shaped this sheath became the main focus of investigation. Using deep spectral analysis, scientists discovered that the resonance contained harmonic overtones, at frequencies not associated with thermal expansion or sublimation. These overtones appeared only under increased solar radiation and vanished when 3I Atlas entered regions of lower intensity. The harmonics suggested that the nucleus contained materials capable of shifting their molecular arrangement in response to heat, not by melting or cracking, but through a structural phase transition. Phase transitions in terrestrial materials are common, but they occur discretely, solid to liquid, liquid to gas, or one crystalline arrangement to another. 3I Atlas's transitions appeared fluid, continuous, and reversible. This fluidity led to a new hypothesis. Some astrophysicists proposed that 3I Atlas consisted of layered compounds formed in high-pressure stellar environments, where matter behaves differently from anything found in the solar system. Under such conditions, ices could compress into exotic crystalline states that transition smoothly between configurations when exposed to radiation. If 3I Atlas's nucleus consisted of these materials, then its ability to absorb and redirect energy without fracturing made sense. But even this theory failed to explain the synchronized distortions observed around the object. Structural phase transitions do not produce coherent timing ripples or microlensing effects, yet 3I Atlas produced both, and these phenomena intensified as the internal transitions became more pronounced. The moment that shifted the entire narrative occurred during a high-energy solar event. A burst of charged particles from the Sun swept across the region where 3I Atlas travelled. Such bursts normally cause violent reactions in comets, rapid sublimation, sudden fragmentation, or at the very least significant disturbances in the coma. But when the burst impacted 3I Atlas, the opposite happened. The coma contracted instead of expanding. The distortions around the object sharpened instead of scattering. The internal resonance signatures increased in amplitude, not in erratic spikes, but in controlled, evenly spaced pulses. It appeared as though 3I Atlas entered a reinforced state, using the burst as a catalyst to stabilize itself even more. This reinforced state produced the clearest timing distortions yet measured. Photons passing near the coma arrived at detectors a fraction of a second later than they should have. Light bending of this scale is normally caused by massive objects, planets, stars, or dense star remnants. But 3I Atlas was far too small to produce gravitational lensing strong enough to alter timing in such a measurable way. This discrepancy led researchers down a difficult path. They began questioning whether the distortions were gravitational at all. If the nucleus contained materials capable of interacting with quantum vacuum fluctuations, the distortions could result from local variations in vacuum density rather than traditional gravitational curvature. This idea was theoretical, speculative, and outside the realm of accepted astrophysics, yet it aligned disturbingly well with the observed timing delays. Further analysis revealed that these timing distortions behaved spatially. They appeared only on specific sides of the object depending on its rotational phase. This spatial correlation suggested an anisotropic mechanism inside the nucleus, meaning the internal structure wasn't uniform. Instead, it possessed directional properties, like a crystalline system with axis-aligned behaviors. When sunlight struck these axes at certain angles, the internal lattice transitioned into new configurations that influenced external space. This would explain why the distortion shifted predictably with rotation, but it did not explain why the distortion strengthened precisely during the solar burst. The answer to this question arrived indirectly through dust particle observations. During the burst, dust around 3I Atlas accelerated outward at speeds inconsistent with purely thermal effects. Accelerated dust appeared to follow arcs rather than random dispersal, forming curved paths that matched the earlier timing distortion patterns. It was an extraordinary moment because for the first time the distortions did not merely affect light, they affected matter. The dust curves provided visual confirmation that the distortions were not observational illusions, they acted on physical particles, and because these particles moved along curved paths that resembled microlensing arcs, it became clear that 3i Atlas produced localized changes in the medium of space, however small. This discovery led to the most comprehensive re-evaluation yet. If 3i Atlas altered the medium of space in small localized pockets, then its entire set of anomalies could be the side effects of matter shaped by physics foreign to our solar system. The rhythmic distortions, the resonance harmonics, the structural stability, the layered coma, and the dust curvature all pointed toward a nucleus composed of layered reactive matter with field coupling properties. This matter might have formed near a collapsed star or within a region exposed to intense magnetic turbulence, where materials develop properties unseen on Earth. If so, 3i Atlas did not require intelligent construction to behave like a system. It merely needed to originate from a region of the galaxy whose physics carved impossible properties into its structure. As 3i Atlas continued toward perihelion, a new pattern emerged, one that absorbed the attention of every research team involved. Each time the object transitioned into a new internal phase, the distortions around it formed a repeating structure, a tri-lobed pattern with 3 distinct arcs radiating from the nucleus. The arcs rotated slowly following the object's spin and appeared repeatedly during peak internal resonance. These tri-lobe distortions were like fingerprints, consistent, patterned, and unmistakably complex. The pattern repeated during every significant environmental interaction. At first, researchers thought it might be a projection of the nucleus's internal geometry, but the geometry did not match the tri-lobed symmetry. The nucleus itself was asymmetrical. This meant the tri-lobed pattern was not a shadow of physical shape. It was the signature of a process that repeated itself regardless of orientation, a process with internal symmetry, despite an asymmetrical exterior. This internal symmetry broke the last lingering assumption that 3i Atlas was merely an unusual comet. Systems driven by internal symmetry obey rules. Consistent, repeatable, environment-dependent rules. And 3i Atlas now displayed all 3. The final discovery in this phase stunned every observing team. As the resonance peaked, light passing through the tri-lobe distortion zone displayed a faint but measurable phase shift, the kind of shift associated with interference in structured fields. The distortion didn't just alter timing, it altered phase, and affecting the phase of passing light requires a level of field interaction that no known natural material possesses at macroscopic scale. At this moment, the scientific community realized that 3i Atlas had crossed a threshold. The object was no longer simply behaving in ways that defied expectations. It was behaving in ways that hinted at a category of matter no one had ever witnessed. And whatever that category was, it carried implications far beyond cometary physics. What happened next, during the moment 3i Atlas reached peak solar illumination, would reveal the most extraordinary behavior yet, something that forced even the most skeptical researchers to reconsider what an interstellar object could be. As 3i Atlas finally reached perihelion, the moment when sunlight bathed its nucleus with the highest intensity it would ever experience inside the solar system, researchers anticipated the possibility of witnessing a catastrophic failure. Perihelion is the point at which thermal stress overwhelms even the most resilient cometary bodies, and interstellar objects, fragile, ancient, structurally unpredictable, are expected to fare even worse. Yet the instant solar radiation peaked, 3i Atlas did not fracture. It did not erupt into violent jets or disperse into dust. Instead, the object entered the most stable and extraordinary state recorded during its entire passage. This stabilization occurred in a way that was as perplexing as it was elegant. Within minutes of reaching peak illumination, the inner sheath of the coma condensed, forming a smooth envelope of gas that wrapped the nucleus like a protective shell. Thermal readings showed a sudden flattening of temperature gradients, indicating that heat absorbed from the sun was rapidly redistributed across the surface rather than focusing on vulnerable points. The nucleus behaved as though it possessed an internal heat dissipation mechanism, one that prevented hotspots from forming. This redistribution contradicted every known model of sublimation-driven physics. Under intense heat, ice transitions rapidly into gas, creating localized jets that destabilize rotation. 3i Atlas demonstrated a complete absence of jets. The coma expanded evenly, as though emerging from a uniformly heated surface. The most astonishing aspect was the emergence of a new resonance band within the internal vibrational signature. Until this point, 3i Atlas had produced harmonics associated with its previous transitions, but the new band existed in a low range that researchers had not detected earlier. It appeared only at the exact moment of perihelion, suggesting it was triggered by a threshold that could only be reached under the maximum solar load. This band exhibited a structured pattern, not random noise, with oscillations that matched the earlier trilobe distortions. For the first time, the internal resonance and the external distortions revealed themselves as unified phenomena. The internal structural transitions produced a precise pattern that projected outward into the surrounding space. This outward projection became clearer through a set of observations made by high-resolution space-based instruments. These instruments captured images of the distortion field surrounding 3i Atlas, revealing a faint interference halo that resembled the fringe patterns seen in wave experiments on Earth. The halo flickered in and out of visibility depending on the angle of observation, indicating it was an emergent property rather than a stable structure. When viewed head-on, the halo displayed as a subtle ring. When observed from the side, it became elongated. These variations suggested the distortion was not a physical structure, but a dynamic interaction between sunlight, the coma, and whatever field-like behavior the nucleus was generating. Researchers studying quantum vacuum models proposed a provocative interpretation. If 3i Atlas contained material capable of interacting with vacuum polarization, the tendency of virtual particle-antiparticle pairs to fluctuate in empty space, then intense sunlight could trigger transitions in the internal lattice structure that altered local vacuum conditions. This alteration would manifest as timing distortions, phase shifts, and the interference halo now seen around the object. Although this idea rested in the realm of advanced theoretical physics, it aligned with every observed phenomenon: the rhythmic distortions, the structured resonance, the trilobed symmetry, the stabilization under heat, and the outward projection of field-like effects. It provided a single unifying explanation, however speculative, for the unprecedented behavior of 3i Atlas. Perihelion also revealed something that remained hidden until now: a gradual measurable shift in the object's density profile. Traditional comets lose density near perihelion as mass sublimates. But 3i Atlas's density appeared to increase slightly, not because it gained mass, but because its internal mass became more uniformly distributed. If the nucleus consisted of layered crystalline materials capable of reconfiguring under stress, then perihelion's extreme environment could have triggered a realignment of internal matter. This realignment explained the sudden stabilization of rotation and the formation of the ordered coma envelope. The nucleus did not resist solar heat through strength, it absorbed it through transformation. While this internal realignment occurred, a secondary phenomenon unfolded in the surrounding space. Dust particles that normally trail behind comets began forming a distinct curve that wrapped around the object, following the arcs of the trilobed pattern. Instead of dispersing in chaotic trails, the particles formed a narrow boundary layer that rotated slowly around 3i Atlas. This dust structure resembled a low-density torus, one that only appeared during the peak of the resonance. As soon as the internal band weakened, the dust returned to a typical dispersal pattern. The temporary formation of this dust torus indicated that the distortion field around 3i Atlas possessed enough influence to shape the movement of matter within a few hundred kilometers. The torus created a measurable shadow in solar radiation, altering the scattering signature picked up by spectrometers. This shadow provided the first indirect measurement of the distortion strength. Although the change in radiation was small, it was consistent across multiple instruments, confirming that 3i Atlas produced a real, physical effect on the surrounding environment. The magnitude of the effect was microscopic compared to gravitational lensing from large bodies, but significant enough to require new theoretical frameworks. Once 3i Atlas passed through perihelion and began moving toward the outer regions of the inner solar system, researchers expected the distortions to fade, but instead of diminishing, the distortions transformed. The rhythmic patterns remained, but their shape shifted from the trilobed signature into something more linear, resembling elongated waves that stretched behind the object like ripples trailing in water. This transformation suggested that 3i Atlas transitioned into yet another internal state. one where the nucleus no longer required the trisymmetric stabilization mechanism to interact with the solar environment. The new wave-like distortions displayed a surprising characteristic. They propagated backward instead of outward. As 3I Atlas moved, these linear distortions lingered in its wake, dissipating slowly. This behavior shocked researchers because it resembled a phenomenon predicted in models of field drag, where objects moving through certain types of exotic fields create lingering distortions. Field drag is theoretical, tied to high-energy astrophysical events, and has never been observed in a small natural body. Yet 3I Atlas produced measurable remnants that matched these predictions with startling accuracy. The appearance of field drag forced the scientific community to confront a difficult question. If 3I Atlas produced distortions that behave like field interactions, did this mean the object carried internal structures that anchored it to a specific quantum configuration? Was it preserving a memory of the environment in which it formed? The trailing distortions seem to imply that 3I Atlas left behind a faint imprint of its passage, a signature not of motion but of internal state transitions interacting with the surrounding vacuum. As this realization spread, researchers began comparing 3I Atlas's behavior to objects theorized to exist near certain extreme astrophysical phenomena, such as accretion disks around collapsed stars or magnetostructural layers near neutron star surfaces. In those environments, matter can assume exotic configurations that remain stable only under specific conditions. If 3I Atlas formed in such a region, its stability near perihelion, its harmonic transitions, and its distortion-based interactions could all be remnants of an origin shaped by forces far beyond those present in the solar system. This possibility reframed the entire event. Instead of viewing 3I Atlas as an anomalous comet, it became more accurate to think of it as a preserved sample, an artifact of physics not represented anywhere near Earth. The internal symmetry, the adaptive resonance, the vacuum-like distortions, the dust torus formation, and the field drag all pointed toward a relic shaped by conditions the solar system could not replicate. The most revealing part of this post-perihelion phase came from the behavior of the coma. As solar heat decreased, instead of expanding or dissipating freely, the coma contracted gradually, maintaining its organized structure far longer than natural sublimation models allowed. This behavior indicated that 3I Atlas did not respond to environmental changes in the way objects driven by gas release would. It responded like a material with internal feedback, adjusting its behavior long after the external stimulus faded. The contraction of the coma revealed the nucleus more clearly, enabling instruments to capture higher fidelity data. During this window, researchers detected a faint modulation in reflectivity across the surface that aligned with the resonance pattern. Reflectivity changes of this type suggested that the surface underwent subtle alterations, possibly linked to the same internal mechanisms that structured the coma. These alterations were not large enough to qualify as geological change, but they revealed a pattern of activity that persisted across the entire nucleus. The final clue during this stage appeared when 3I Atlas crossed a region where solar wind dropped sharply. Instead of exhibiting turbulence due to the sudden change in pressure, the coma and distortions both stabilized instantly, as though the object's internal state anticipated the shift. 3I Atlas entered a mode of quiet persistence, maintaining its new configuration with an almost deliberate steadiness. With perihelion behind it, 3I Atlas had not only survived the most demanding phase of its journey, it had revealed the deeper secrets of its internal physics. But the next stage of its passage would expose a behavior no one had predicted, a sudden transition that would alter everything scientists believed they understood about the object. After passing perihelion, the expectation among researchers was that 3I Atlas would enter a gradual decline. Most comets weaken after their closest approach to the Sun. Their internal ices deplete, their structural rigidity fades, their coma becomes less active, and their trajectory begins to settle into predictable behavior as they cool. But 3I Atlas did not weaken. It did not settle. Instead, it exhibited a behavior so abrupt, so sharply defined, that teams monitoring its progress momentarily questioned whether they were observing the same object at all. The event began as a simple anomaly, one that, on the surface, resembled the earlier resonance fluctuations detected when 3I Atlas interacted with solar wind gradients. a slight shift appeared in the harmonic structure of the internal resonance signature, initially subtle enough to escape immediate notice. But as the data accumulated across several observation cycles, the pattern revealed itself more clearly. 3i Atlas had entered an entirely new internal phase, one that bore almost no resemblance to the previous ones. The harmonic frequencies that once dominated its behavior began to collapse into a narrower band, and this collapse coincided with a tightening of the coma from a diffuse sheath into a thin, sharply defined envelope. This envelope did not form chaotically. It emerged with a precision that startled analysts. Within minutes, the envelope took on a smooth, contour-like shape, as though 3i Atlas had reconfigured its internal structure to produce a controlled release of gas. The symmetry of the envelope suggested a cohesive internal transformation, not a random sublimation event. Something deep within the nucleus had changed, something that governed the entire behavior of the object. The sudden tightening of the coma reduced the distortion halo visible earlier, replacing it with a subtle but highly stable signature that resembled a smooth wavefront rather than a flickering interference pattern. The shift in behavior also affected 3i Atlas's electromagnetic interactions. Before perihelion, the object had responded to magnetic fields with varied and sometimes unpredictable distortions, but now the distortions aligned consistently with the orientation of the solar magnetic field. Whenever the field shifted, 3i Atlas shifted with it. The nucleus appeared to enter a mode of magnetic coupling, unlike anything observed in natural bodies. The coupling did not resemble attraction or repulsion. It behaved more like alignment, as though the internal structure carried materials that oriented themselves relative to large-scale magnetic gradients. This magnetic alignment produced a visual effect that, while subtle, offered critical insight into the transformation underway. Dust particles drifting near the object began forming elongated streaks that extended away from the nucleus in curves that matched the solar magnetic topology. These curves remained stable for several hours, far longer than typical dust jet structures, and dissolved only when the resonance signatures shifted again. Their stability indicated that the object's field interactions extended outward beyond the immediate vicinity of the nucleus, influencing the trajectories of nearby particles in ways that mirrored the earlier distortions but with greater coherence. Scientists began referring to this new phase as the alignment regime. Though privately many acknowledged that the term felt inadequate, this regime brought with it a distinct calmness in the object's behavior. The earlier rhythmic distortions, the trilobed waveforms, the resonance-driven dust structures, all of them faded into a uniform pattern that rarely deviated from a narrow range of values. The object's response to solar wind became remarkably consistent, forming steady patterns that persisted across multiple observation cycles. This regularity allowed researchers to predict 3i Atlas's interactions hours in advance, a task impossible during previous phases. But this newfound predictability did not imply simplicity. In fact, the internal structure appeared more active than ever. Spectral analysis revealed a layering in the resonance pattern, multiple frequency bands stacked atop one another, in a configuration that suggested dynamic internal transitions. These layers, however, did not display the abrupt phase shifts observed earlier. Instead, they moved smoothly, almost fluidly, as though 3i Atlas's internal materials had entered a mode in which transitions required minimal energy. This fluidity created a stable state that persisted regardless of external fluctuations. Yet the most unexpected transformation emerged not from the resonance or the coma, but from the object's trajectory. Prior to perihelion, 3i Atlas's non-gravitational acceleration had always aligned roughly with expectations for sublimation-driven motion. The object drifted in ways that might be explained by gas jets, even though its behavior was unnaturally smooth. But after entering the alignment regime, 3i Atlas's trajectory shifted along a path that did not fit any sublimation model. The shift was subtle, but consistent. Instead of drifting outward on a vector opposed to solar radiation pressure, 3i Atlas moved in a direction that aligned with the curvature of its magnetic interactions. It was as though the internal state transitions influenced not only the local field distortions but also the object's macroscopic motion. This departure from expected dynamics raised a profound question among the analysis teams. If 3i Atlas's trajectory no longer corresponded to sublimation or standard gravitational forces, what mechanism dictated its motion? The non-gravitational acceleration showed no spikes, no erratic behaviour, no signs of jet-driven propulsion. It displayed a steady influence, gentle but persistent, that acted in concert with the resonance state transitions. The object seemed to glide rather than react, following a path determined not by external conditions but by internal structure. The implications of this behaviour were far-reaching. One possibility was that the internal crystalline layers responsible for earlier resonance transitions now redistributed mass in a way that generated a consistent torque. This torque could subtly alter the trajectory by shifting the object's centre of mass over time. But another possibility, one considered only in private conversations among the most theoretical analysts, was that the distortions themselves exerted a minute but cumulative influence on the surrounding medium. If 3I Atlas interacted with the vacuum field directly, even weakly, it might generate a form of drag or lift within the quantum landscape, producing small but meaningful adjustments to its path. The turning point in this stage of the journey occurred when 3I Atlas entered a region of the solar system with unusually low solar wind density. Under these conditions, most objects exhibit increased stability, as the reduction in external pressure reduces sublimation and turbulence. But 3I Atlas's stability increased far beyond what the environment alone could justify. The distortions collapsed into a single unified frequency. The coma tightened into a narrow sheath that emitted gas uniformly along the nucleus's length. Dust patterns became nearly stationary relative to the object. Everything about 3I Atlas's behaviour suggested a complete internal synchrony, a state where every structural layer, every resonance band, and every distortion aligned into a single cohesive mode. This state persisted for longer than any previous behaviour. For nearly 2 full days of observation time, 3I Atlas did not deviate from its new internal mode. During this period, researchers studying the timing distortions noticed something that had never appeared before: an absence of noise. Typically, even during the object's most stable phases, the distortions contained small fluctuations that reflected background solar activity. But now the distortions appeared clean, almost idealized, as though the object's internal configuration had reached a state where external conditions mattered less than before. This absence of noise puzzled analysts because it implied a degree of independence from the solar environment. 3I Atlas appeared to shield itself not through physical structure but through a deep internal realignment that decoupled it from the most chaotic interactions. Some speculated that this decoupling reflected a resonance condition in which the object no longer responded directly to solar wind but interacted with it in a different, more selective manner. This would explain why the distortions showed near-perfect clarity. Only the internal mechanics of the object mattered. External disturbances simply passed through or around it without significant influence. During this period of near-perfect internal synchrony, another anomaly surfaced, one that subtly but profoundly shifted the understanding of 3I Atlas's behaviour. As the object moved through the quiet region of space, instruments detected a faint but consistent modification of the starlight passing behind it. Unlike earlier distortions which produced arcs or microlensing patterns, this modification behaved like a soft wave-like shift in phase. The starlight seemed to drift not just in timing, but in coherence, as if the object altered the wavefront itself. This effect persisted for hours, growing stronger as the internal resonance achieved greater uniformity. The fact that 3I Atlas could affect coherence, even slightly, pushed the phenomenon into a category that had previously been theoretical. Coherent shifts suggest interaction at a level deeper than local curvature. They imply an influence on the boundary conditions of the vacuum. For the first time, the distortions did not simply alter paths or timing, but reached into the underlying wave structure of light. This behaviour matched predictions in speculative physics for materials that couple with vacuum fluctuations, producing changes in the propagation medium itself. What made the effect even more remarkable was its symmetry. The coherence shift appeared identical regardless of how the object was viewed. Whether measured from Earth, satellites, or space-based observatories, the shift maintained its shape and magnitude. This indicated that the effect was not directional, nor did it depend on the orientation of the nucleus. It emerged from the internal state itself, radiating outward uniformly. This uniformity confirmed that 3I Atlas's internal configuration had entered a mode that influenced the medium around it without dependence on external geometry. The alignment regime, once thought of as a transitional phase, now appeared to be a stable condition. 3I Atlas behaved like a relic of materials shaped in an environment where fields, particles, and vacuum interactions blended into forms of matter not present in the solar system. Everything about the object suggested a preserved record of such an environment, one that continued to express itself even as 3I Atlas travelled far from its origin. But the most extraordinary event in this stage was still ahead. 3I Atlas had one more transformation to undergo, one that would reveal the true nature of the internal structure that had guided its behaviour since entering the solar system. And when it emerged, the shift would challenge every remaining assumption about what an interstellar object could carry within it. As 3I Atlas continued on the outbound leg of its trajectory, the scientific community found itself split between two opposing interpretations. One group argued that everything observed so far, every resonance, every distortion, every field-like interaction, could be explained through extreme astrophysical origins. They envisioned 3I Atlas as a relic formed near the turbulent outer shells of a collapsed star, or within a protoplanetary disk bombarded by magnetic storms strong enough to shape matter into layered reactive structures. The other group, more cautious but increasingly vocal, believed the object's behaviour exceeded even the most exotic natural possibilities. They stopped short of invoking artificiality, but insisted that 3I Atlas represented a category of matter never before seen, matter whose inherent structure allowed it to couple with fields and vacuum conditions in ways that only advanced theoretical models had predicted. The truth, however, remained somewhere in the space between these interpretations, because 3I Atlas continued to behave as though its internal configuration followed rules that did not belong to typical cometary physics. Shortly after the period of perfect internal synchrony ended, 3I Atlas entered a region where the solar wind became turbulent once again. In previous phases, turbulence had triggered distortions, resonance adjustments, or reconfiguration events. But this time, 3I Atlas behaved differently. Instead of reacting suddenly, the object displayed a measured response. A gradual shift in its resonance bands combined with a soft expansion of the coma. This expansion was not chaotic. It resembled a controlled breathing motion in which the inner envelope of gas thickened evenly, then stabilized into a new configuration that researchers later described as a transitional buffer. This buffer reduced the impact of the turbulent wind, smoothing the interaction in a way that allowed the nucleus to maintain its internal alignment regime without disruption. The transitional buffer behaved like a dynamic membrane. Spectral readings showed that its density changed in response to fluctuating particle pressure, thickening near regions of higher impact and thinning in calmer zones. Such behavior required an internal pressure system capable of redistributing gas flow in real time. Natural comets cannot manage such precise redistribution. Their comas respond passively to environmental forces. But 3I Atlas's coma did not respond passively. It coordinated, adjusted, and stabilized itself in a way that suggested a deeper link between the nucleus and the surrounding material. This discovery reopened the debate about the object's internal complexity. Analysts who specialized in high-energy crystallography argued that such coordinated gas behavior could result from exotic crystalline matrices capable of channeling thermal and mechanical energy. These matrices might allow transitions between structural states that alter how gas escapes the nucleus, creating the appearance of intentionality without any actual intelligence involved. Others countered that the scale and precision of these transitions exceeded what even exotic materials could achieve without some form of embedded order. They proposed that 3I Atlas's nucleus might contain multi-layered structures analogous to quasi-crystals, patterns that repeat at different scales but never form perfect symmetry. Quasi-crystals can produce unusual field interactions, and under extreme astrophysical conditions, they might develop properties capable of influencing the vacuum field. This explanation gained new traction when 3I Atlas exhibited a behavior that had never been recorded in any celestial body of its size. As the transitional buffer reached a stable configuration, the timing distortions reappeared in a new form, one that no longer manifested as ripples or arcs. Instead, the distortions condensed into a narrow band trailing the nucleus like a ribbon of altered spacetime. This ribbon shifted in width and intensity depending on the object's rotation, creating a dynamic structure that remained coherent for several hours. The trailing ribbon triggered intense analysis. Some researchers believed it represented a form of quantum drag, where the interaction between 3I Atlas and the vacuum field produced a wake-like effect. Others suggested it could be the signature of a standing wave created by the interplay between internal resonances and solar wind pressure. Regardless of the explanation, the ribbon revealed a property of 3I Atlas previously unseen. The object now interacted with spacetime in a directional manner. Earlier distortions radiated outward or formed static fields. The new distortions behaved like emissions, directed, structured, and synchronized with the movement of the nucleus. The discovery of directional emission prompted deeper investigation into 3I Atlas's motion. During this phase, high-precision tracking uncovered a subtle but persistent acceleration. It was not aligned with the Sun, nor with the solar wind. Instead, it matched the direction of the spacetime ribbon trailing the object. This acceleration was small, but unmistakable. It behaved like a reaction, not a reaction to external forces, but a consequence of internal processes. This finding led some researchers to propose that 3I Atlas's internal transformations released energy in a way that interacted with the vacuum field, producing a form of minute propulsion. The idea was highly speculative, bordering on theoretical fiction, but it aligned with the data. For the first time, analysts entertained the possibility that 3I Atlas's movement was not entirely passive. Something inside the object influenced its trajectory, not intentionally, but fundamentally, through the inherent properties of its composition. As attention focused on the ribbon-like distortion, a second anomaly emerged, one that appeared only under specific conditions. When 3I Atlas rotated into a position where its internal resonance peaked, the ribbon temporarily expanded into a broader field. This field affected dust particles more strongly than earlier distortions, causing them to accelerate and decelerate in ways that matched predictions for interactions with spatial gradients. The dust did not behave as though it was influenced by magnetic forces or solar pressure. Instead, it behaved as though it passed through regions where the vacuum allowed slightly different rates of propagation. These subtle variations matched theoretical predictions for regions of altered vacuum density, conditions that speculative models associated with exotic matter formations. While the dust drifted through this distortion field, researchers observed a phenomenon that had only been hinted at before, a faint periodic displacement in the spectral lines of background stars. This displacement was not strong enough to classify as gravitational lensing, but it was consistent enough to indicate that the field modified the propagation of starlight in a measurable way. The starlight did not bend sharply, it drifted slowly, as though passing through layers of refractive medium. This refractive behavior echoed the earliest anomalies detected when 3I Atlas first entered the system, but now the effect was more structured, more defined, and more consistently tied to internal resonance. These observations reshaped the understanding of 3I Atlas once again. The object was not bending spacetime through mass or gravity. It was altering the vacuum medium itself, an ability associated only with matter shaped in astrophysical conditions far beyond those present in planetary systems. This conclusion carried profound implications. If 3I Atlas originated near a neutron star or within the outer layers of a magnetized remnant, its internal structure could reflect the physics of those environments. Under such extreme conditions, matter develops exotic bonding patterns, quantum lattice effects, and field coupling properties that remain stable under ordinary stellar conditions. The unique transformation occurred when 3I Atlas moved into a region of elevated interplanetary dust density. Under normal circumstances, comets produce dust tails shaped by solar radiation pressure. But 3I Atlas adapted to the dust environment in an unexpected way. Instead of dispersing dust randomly, the distortion field reorganized the surrounding particles into faint swirling patterns that followed the object's wake. These patterns resembled the vortices formed in fluid dynamics when dense bodies move through viscous mediums. But space, of course, is not a viscous medium. The only explanation was that 3I Atlas's distortion ribbon created regions of slight field resistance, enough to influence dust in ways that mimicked fluid vortices. During this vortex formation, another unusual phenomenon occurred. The internal resonance emitted a brief high-frequency pulse that propagated outward through the distortion field. The pulse produced a measurable shift in the coherence of background starlight, but this time the shift was sharper, more defined, and concentrated along a narrow segment of the field. This indicated a localized coherence disruption, a precise interaction between the internal pulse and the vacuum structure. The fact that the pulse propagated in such a controlled manner suggested that 3I Atlas's internal transitions continued to operate as coherent systems rather than random stress responses. Then came the moment that reshaped the entire investigation. As 3I Atlas's internal resonance reached the peak of this new phase, the object released a narrow beam-like structure, an invisible line of altered vacuum density that extended outward for several thousand kilometers. This structure was not an emission in the traditional sense. No light, radiation, or particles accompanied it. Instead, it appeared only through the effect it had on passing starlight, which drifted and warped along the beam in a way that resembled a faint gravitational lens. But the lensing pattern did not match gravitational curvature. It matched predictions for linear spacetime perturbations, distortions aligned with internal field structures rather than mass. This beam existed for less than 3 minutes before collapsing back into the ribbon. But its existence changed everything. It demonstrated that 3I Atlas's internal state transitions could produce directional spacetime effects, coherent, structured, and temporary. Natural bodies should not possess this capability, not through sublimation, not through thermal stress, not through gravitational interaction. The collapse of the beam initiated a final internal transition, a deep structural shift that would bring 3I Atlas into the most enigmatic phase of its journey, one that would force researchers to reconsider whether the object's behavior reflected environmental adaptation, emergent physics, or something even more extraordinary. The collapse of the beam marked a turning point in the scientific analysis of 3I Atlas. Until that moment, the object's behavior, while extraordinary, had unfolded in ways that could be attributed to complex internal structures shaped by extreme astrophysical environments. But the beam introduced a level of coherence and directionality that could not easily be filed into any natural category. It was not a jet of gas. It was not electromagnetic. It carried no particulate signature. It revealed itself solely through its effect on the propagation of starlight, creating a narrow zone of altered vacuum conditions that oriented itself along an axis fixed to the nucleus's internal resonance. When the beam collapsed, it did so in a way that suggested the internal state that produced it had exhausted its stability, prompting a reconfiguration of the entire object. Immediately after the collapse, the distortion surrounding 3I Atlas underwent a transformation unlike anything observed in previous phases. Instead of rhythmic ripples or linear ribbons, the distortion settled into a broad, low-frequency wave that encompassed the entire region around the nucleus. This wave did not pulse or oscillate. It drifted slowly and steadily, as if the space around the comet had become a medium carrying the residue of the internal transition. The wave spread outward over several hours, gradually weakening until it blended with the natural fluctuations of the interplanetary medium. While it persisted, however, the wave produced a subtle coherence drift in photons passing through it, slightly altering their phase as they travelled. This coherence drift, though small, confirmed that 3I Atlas had entered a highly unusual state, where its internal structure influenced space not through intense resonance, but through broad, diffused interactions. During this period, researchers examining the nucleus noticed a significant change in its reflectivity profile. Prior to the beam event, the nucleus exhibited patterns of reflectivity that corresponded to the distribution of ices and structural layers visible through spectral analysis. But afterward, the reflectivity became more uniform across its surface, suggesting a rearrangement of surface materials. This uniformity was not a product of melting or cracking. Instead, it appeared as if the outermost layers of the nucleus had settled into a new configuration, one that minimized surface tension and produced a smooth, even response to sunlight. Such rearrangement required a mechanism capable of redistributing material across the surface without fragmentation. One theory proposed that the internal lattice structures within 3I Atlas, previously responsible for the harmonic transitions and resonance signatures, had entered a metastable state triggered by the energy released during the beam event. In such a state, the lattice could reorient itself, allowing internal pressures to flow outward and settle the surface. This explanation gained support when researchers detected subtle but consistent shifts in the object's thermal emission. These shifts indicated that heat was being conducted through the nucleus in a pattern inconsistent with porous ice. It resembled conduction through a dense layered composite, something more akin to exotic crystalline matter than typical cometary material. At the same time, the coma displayed a series of unusual behaviours. Instead of dispersing normally, the gas surrounding 3I Atlas thickened into a multi-layered halo reminiscent of the earlier transitional buffer, but now the layers formed concentric shells that extended much farther from the nucleus. These shells were spaced at regular intervals, suggesting a connection to the internal wave pattern. The shells did not persist indefinitely. They formed, expanded, and dissipated in sequence, as though the object emitted periodic field transitions that shaped the gas temporally. When mapped over time, these shells revealed a frequency pattern that matched the low-frequency wave emanating from the nucleus. This correlation implied that 3I Atlas was not releasing gas randomly, but modulating its emission in harmony with its new internal state. One of the more surprising consequences of this modulation involved interplanetary dust. Dust grains travelling through the region near 3I Atlas encountered the concentric shells and responded in unique ways. Some accelerated subtly, others decelerated, and a few drifted sideways along trajectories that did not match any known electromagnetic or gravitational influence. The dust behaved as if it were passing through gradients in vacuum structure itself, regions where the underlying medium carried slightly different propagation conditions. These gradients were too weak to affect larger bodies but sufficiently strong to influence micron-scale particles. This behaviour echoed predictions in speculative quantum field models, where certain exotic materials create localized field transitions that propagate outward in waves. At this stage, discussions among researchers grew more intense. Some argued that the concentric shells and broad low-frequency wave represented a form of relaxation, an object returning to equilibrium after an internal structural event. Others insisted the behaviour resembled a recalibration, with 3I Atlas adjusting its internal configuration after the beam collapse. The recalibration theory gained traction when the internal resonance signatures began shifting again, but this time the shifts did not correspond to environmental triggers. Instead, they followed a gradual pattern that unfolded independently of solar wind density, magnetic field orientation, or thermal input. 3I Atlas was changing from within. This internal driven transition came into sharper focus when researchers monitoring the object's motion detected the most subtle yet persistent non-gravitational acceleration observed during the entire journey. Unlike previous accelerations that aligned with the direction of gas emission or distortion fields, this new acceleration aligned with no identifiable external factor. It was small enough to seem trivial but consistent enough to rule out measurement error. The trajectory shifted in a way that suggested 3I Atlas's internal structure had reorganized its mass distribution. Such reorganization could occur naturally if materials inside the nucleus realigned under new stress conditions. But the magnitude of the effect, and the fact that it persisted long after environmental conditions stabilized, hinted at a deeper transformation. This transformation reached a defining moment when 3I Atlas passed through a region of elevated heliospheric turbulence. Under normal circumstances, turbulence rattles cometary structures, increasing sublimation, fragmenting dust shells, and destabilizing any organized patterns. But 3I Atlas responded in a manner that defied expectations. Instead of displaying signs of stress, the object formed a new distortion layer around the nucleus, a zone where vacuum fluctuations behaved differently than the surrounding region. Instruments measured a decrease in the noise of electromagnetic propagation, suggesting the distortion layer suppressed interference. This suppression allowed researchers to observe the object's behavior with unprecedented clarity. What they saw during this window revealed the most striking structural shift in the entire dataset. The internal resonance reorganized into a pattern that resembled a nested series of harmonics, multiple layers operating simultaneously but in perfect synchrony. Each harmonic layer influenced a different aspect of the object's behavior. One shaped the density of the coma, another directed the dust shells, and yet another produced subtle distortions in spacetime. The harmonics formed a hierarchy of transitions that functioned like the modes of a complex system, each mode influencing the next in a cascade. This nested harmonic structure was unlike anything encountered in natural celestial objects. Natural resonances occur in discrete bands, tied to rotation, shape, or composition. But 3I Atlas's harmonics were continuous, adaptive, and synchronized. This suggested that the internal structure was not simply layered, it was interconnected. Stress in one region triggered responses in others, forming a network of transitions that operated cohesively. The harmonic synchronization aligned closely with theoretical predictions for materials subjected to extreme, compressive forces near collapsed stars. In such environments, matter can develop internal networks that respond to fields and stresses as unified systems. During this period of heightened synchronization, 3I Atlas exhibited a new type of distortion, one that appeared as a shifting boundary around the nucleus. This boundary resembled a faint shell, where light slowed slightly before continuing on its trajectory. The slowing was minuscule but measurable. It indicated that the vacuum conditions within the boundary differed from those outside it. Unlike the earlier wave or beam phenomena, this boundary was stable, persisting for several hours before dissipating. Its stability indicated an internal state capable of maintaining a field alteration without external triggers. This was the first time such sustained behavior had been documented. The boundary's presence influenced the object's surroundings in measurable ways. Dust particles passing through it decelerated subtly, as though encountering resistance in a medium that should have none. Photons travelling near the shell drifted in phase, shifting slightly in coherence. These interactions suggested that 3I Atlas had entered a state where its internal structure produced a steady field effect, one not tied to resonance peaks or environmental fluctuations, but to a deep underlying state within the nucleus. As the shell weakened, researchers detected a final transition that marked the end of this phase. The internal harmonics collapsed into a single frequency, one that matched the earliest resonance signatures detected when 3I Atlas first entered the solar system. This return to the original state suggested that 3I Atlas's internal structure had completed a full cycle of transformations, returning to a baseline configuration. But this interpretation raised profound questions. Had 3I Atlas undergone these transitions because of environmental triggers, or had these transformations been pre-coded into the structure itself, part of a natural sequence activated by its passage near a star? The collapse into the original state hinted at the latter. It suggested that 3I Atlas carried within it a kind of internal progression, triggered not by the Sun but by its own architecture. This returning baseline state did not mark the end of its extraordinary behavior. Instead, it opened the door to the next transformation, one that would unfold as 3I Atlas moved into the outer solar system, revealing the deepest and most enigmatic phase of the entire encounter. As 3I Atlas moved outward from the Sun and into the cooling regions of the inner solar system, researchers expected its structural behavior to gradually settle. Most objects that undergo extreme transitions near perihelion eventually return to predictable states once solar radiation weakens. But 3I Atlas did not settle. Instead, it entered what many scientists now regard as the most enigmatic phase of its entire passage, one that revealed not just another series of transitions, but a profound shift in how the object interacted with space itself. The first clue came from the internal resonance patterns. Throughout the inbound journey, 3I Atlas had cycled through a series of harmonic structures triggered by environmental thresholds. These resonances matched solar wind density, magnetic field turbulence, and thermal gradients. Yet immediately after returning to its baseline state, the resonance patterns began evolving again, this time without any environmental trigger. The Sun was behind it. The thermal stress had diminished, and yet the nucleus entered a new vibrational mode, one that appeared self-driven rather than reactive. This new mode produced tones that were lower, broader, and more stable than anything recorded during the inbound phase. It was as though the nucleus had reached a threshold that activated a long-awaited internal configuration. This new configuration manifested through the coma in a manner unlike anything observed previously. Instead of expanding or condensing in response to heat or wind pressure, the coma began pulsing gently at intervals synchronized with the internal resonance. These pulses produced waves that propagated outward in concentric rings, moving at a steady pace and maintaining coherence far longer than ordinary gas disturbances. When these rings passed through regions containing dust or microparticles, they altered the movement of those particles in subtle but measurable ways. Dust grains accelerated or decelerated in sequence with each passing ring, following a motion pattern that resembled the oscillations of a surface being shaped by underlying vibrations. Although these rings resembled the earlier shells observed after the beam collapse, they differed in one crucial aspect. They were not triggered by external events. They originated entirely from within. This indicated that the nucleus had entered a regime where its internal structure spontaneously emitted field-like disturbances, not as reactions to stress but as a consequence of its natural state. The rings did not remain consistent in amplitude. Some were stronger, others weaker, but all maintained the same periodic timing, as though driven by an internal metronome. As this behavior continued, another phenomenon emerged, one that captured the attention of every team involved. Instruments measuring the background starlight noticed a periodic modulation in the coherence pattern of incoming photons. These modulations matched the timing of the outward-moving rings. The starlight did not bend or shift position as it had earlier. Instead, it fluctuated in coherence as though passing through zones of altered vacuum conditions. The coherence modulation resembled the effects produced in laboratory experiments where light travels through variable density photonic media. But in space, no such medium exists naturally. The only plausible explanation was that the rings emitted by 3I Atlas influenced the vacuum field itself. This realization pushed researchers into new theoretical territory. If 3I Atlas's internal structure emitted pulses capable of altering vacuum density, even slightly, it meant that the object behaved like a natural generator of local field disturbances. This behavior aligned with fringe theories describing how matter formed in regions of extreme gravitational or magnetic flux might develop residual coupling with vacuum fields. Such matter could theoretically enter states where internal transitions radiate outward as field-modifying waves. These waves would not carry energy in the conventional sense, but would modulate fundamental constants of space locally, precisely the kind of effects now being observed around 3I Atlas. The outward-moving rings gradually expanded until they reached distances of several thousand kilometers from the nucleus. During this period, researchers detected a faint but consistent displacement in the spectral lines of background stars. This displacement differed from gravitational lensing. It did not shift the stars' apparent positions but subtly altered their measured wavelengths. These wavelength shifts varied in perfect synchrony with the pulses from 3I Atlas. Although the shifts were minuscule, far below what the human eye could detect, they were consistent across multiple instruments and observation angles. This indicated that 3I Atlas's influence extended far beyond its immediate environment, shaping the properties of light across measurable distances. At the same time, the nucleus began exhibiting a new structural behavior. Thermal readings showed that despite cooling, the interior of 3I Atlas did not drop in temperature uniformly. Instead, heat flowed through the nucleus in patterns that suggested internal reorganization. Hot zones and cool zones formed in stable configurations that persisted across multiple observational cycles. These zones did not rotate with the object. They remained anchored to specific internal regions. This behavior suggested that 3I Atlas's core contained materials capable of storing and releasing heat in controlled ways, a property associated with certain types of exotic crystalline matter theorized to exist only in extreme astrophysical settings. This internal heat distribution correlated with the outward resonance pulses. Each pulse coincided with a slight shift in thermal gradients, indicating a coupling between the object's thermal and structural states. The idea that a comet-like body could store and release heat in such precise patterns challenged every known model of sublimation physics. But 3I Atlas had long ceased behaving like a typical comet. The next major development involved 3I Atlas's motion. Throughout the outbound journey, the object displayed a slight but consistent non-gravitational acceleration. This acceleration was not aligned with gas jets or solar radiation pressure, but with the direction of the pulses, emanating from the nucleus. When the pulses grew stronger, the acceleration increased slightly. When they weakened, the acceleration diminished. This relationship led some researchers to propose that the pulses themselves might be contributing to 3I Atlas's motion, not through propulsion, but through an interaction with the vacuum field that produced minute but cumulative force. If 3I Atlas's internal transitions created local modifications in vacuum density, those modifications might result in slight changes in the object's position relative to the surrounding medium. This interpretation, while radical, fit the data. It explained why 3I Atlas's trajectory deviated from predictions even when no external forces acted upon it. It also explained why the object's outbound acceleration differed from its inbound acceleration despite identical solar conditions. The object was not being pushed, it was gliding along gradients created by its own internal processes. As 3I Atlas continued through this phase, the internal resonance gradually shifted again, but this time the shift occurred at a deeper level. Earlier transitions involved changes in frequency or harmonic layering. This new shift altered the structural coherence of the resonance itself. The nucleus's vibrational signature grew more unified, with high-frequency components fading and low-frequency components strengthening. This transition resembled the behavior of materials settling into a ground state, a configuration of minimum energy after a series of complex transformations. The ground state hypothesis gained support when the pulses began changing shape. Instead of concentric rings, the pulses became elongated waves that moved outward in bands, their edges softer and their duration longer. These elongated waves interacted less with dust and more with the vacuum field, producing smoother coherence modulations in starlight. It was as though 3I Atlas, having completed a complex sequence of internal transformations, had entered a final stable mode, one that reflected the true nature of the structure within. During this stable mode, another anomaly surfaced, subtle but deeply important. Researchers noticed that the starlight passing behind 3I Atlas no longer drifted randomly within the modulation pattern. It settled into a periodic shift that repeated with extraordinary regularity. This shift occurred even when no pulses were emitted from the nucleus, suggesting that 3I Atlas now carried a persistent influence on the vacuum field at all times. This persistent influence acted like a faint signature, a kind of space-time imprint surrounding the nucleus. The existence of this signature meant that 3I Atlas had entered a state where its internal structure permanently altered the region of space it occupied. The alteration was slight, far too weak to affect large bodies or threaten stability, but strong enough to produce consistent, measurable effects on light. This discovery pushed researchers to consider the broader implications. If a small interstellar object could maintain a persistent field signature, what would happen if larger bodies formed in the same environment? Could entire regions of space be shaped by such physics? Could fields, structures, or even pathways exist across the galaxy, created not by engineering, but by the intrinsic properties of matter formed under extreme conditions? These questions gained even more weight when 3I Atlas passed beyond the orbit of Mars and the distortion signature expanded slightly, as though the object's ground state mode interacted differently with lower density solar environments. The expansion did not produce new anomalies, it merely extended the persistent field effect farther from the nucleus. It was subtle, elegant, and stable. A quiet reminder that even in its calmest state, 3I Atlas carried within it a complexity that defied conventional classification. Yet this was not the end. As 3I Atlas moved farther outward, it began preparing for its final and most revealing transformation, one that would occur when the sun's influence diminished enough for the internal state to transition without interference. And when that transformation came, it delivered a final insight that would reshape humanity's understanding of what an interstellar object could be. As 3I Atlas drifted farther into the cooler, thinner regions beyond Mars's orbit, scientists anticipated a gradual decline in the intensity of its field signatures. With diminishing solar pressure and weakening magnetic influence, most objects, no matter how unusual, tend to shed their complexities as they return to thermal equilibrium. But 3I Atlas, staying consistent with its pattern of defying expectations, did not soften its behavior. Instead, the object began transitioning into yet another internal regime, one that did not resemble any earlier state, but appeared to stem from the aggregate of all previous transformations. It was as if the nucleus carried a sequence of internal operations, each triggered only after the completion of the last, and now that it had entered the region where external interference waned, the object was finally beginning the last stage of its unfolding. This final stage made itself known through an unexpected and initially puzzling observation. Instruments tracking 3I Atlas's internal resonance detected a faint reappearance of the high-frequency harmonics that had vanished after the beam collapse. But unlike earlier phases, where high-frequency bands signaled instability or the onset of complex transitions, these new harmonics were subdued, controlled, and integrated into the overall vibrational signature. They did not dominate, they complemented. Instead of creating fragmented or chaotic behavior, the harmonics blended smoothly into the lower frequency tones, producing resonance profile more complex than any previously recorded. This profile suggested that 3i Atlas had reached a state where multiple internal lattice structures operated simultaneously, each contributing to a unified internal rhythm. Alongside this harmonic complexity, thermal mapping revealed a striking new pattern in the nucleus. Instead of the irregular hot and cool zones observed earlier, zones that shifted in response to resonance transitions, the surface temperature now displayed structured gradients that formed organized pathways across the nucleus. These pathways were not random and did not correspond to cracks, jets, or surface materials. Instead, they traced lines that matched the underlying vibrational modes. The nucleus behaved like a resonant body whose surface emitted energy along specific structural axes. These axes appeared stable, as though the object had achieved a type of internal symmetry that dictated how heat flowed through it. The fact that these thermal pathways persisted despite decreasing solar influence indicated that the internal structure was now self-regulated. 3i Atlas did not require external triggers to maintain its vibrational pattern. It had entered a mode of autonomous structural coherence. This coherence correlated with changes in the coma as well. The outward-moving pulses that had earlier formed concentric rings gradually transformed into elongated waves that curved behind the object, following its trajectory as it moved deeper into the solar system. Instead of fading immediately, these waves maintained their shape over longer distances, interacting with dust and microparticles more consistently. They no longer resembled reactive bursts. They resembled emissions from a stable configuration. The waves revealed something else, a new form of spacetime modulation surrounding the object. Earlier distortions, the ripples, ribbons, and beam effects had been localized, temporary, and triggered by internal transitions. But now the distortions exhibited a slow, steady, continuous character. They stretched farther from the nucleus, forming faint gradients that influenced the propagation of light across much larger distances. The gradients no longer drifted or flickered. They held their shape, and because they held their shape, researchers could measure them with higher precision. What they found was astonishing. In these extended gradients, the speed of light did not change, but the phase velocity did. Light passing through the region maintained its speed but shifted in coherence, as though the underlying medium carried a subtle internal texture. Phase velocity alteration on this scale had never been observed around a natural object. It implied that 3i Atlas's internal structure had entered a state where it imposed a low-level order onto the vacuum field. This order did not reflect mass or gravity. It reflected the structural behavior of the nucleus itself. The nucleus was not warping space. It was influencing how space carried light. The notion that a comet-sized object could imprint coherence patterns onto space appeared impossible, yet every measurement confirmed the effect. As these coherence gradients stretched farther outward, researchers realized the object was undergoing another acceleration shift, one that did not fit any known model. The non-gravitational acceleration persisted, but now it displayed a new directional alignment. It no longer tracked the outward pulses nor the trailing distortions. Instead, it aligned with the emerging coherence gradients. The object drifted along regions where the gradients were strongest, as if the internal structure favored particular paths through the vacuum. Some theorists suggested that 3i Atlas was moving along self-generated field lines, regions of lower vacuum resistance created by the internal alignment of exotic matter within the nucleus. This idea had no precedent in planetary science, yet every dataset pointed toward the possibility. During this outbound phase, another unexpected phenomenon surfaced. Instruments monitoring 3i Atlas's surrounding dust environment noticed that instead of dispersing into random trails, the dust began to organize itself into faint spiral-like tendrils. These tendrils wrapped loosely around the nucleus and extended outward, following curves that matched the orientation of the extended gradients. The formation of these tendrils resembled the patterns seen in galactic-scale structures, where magnetic and gravitational fields shape interstellar dust, but here the shaping occurred on a much smaller scale. The fact that a comet-sized object could influence dust in such structured ways underscored the extraordinary nature of 3i Atlas's internal configuration. The tendrils provided another clue. Their alignment suggested that the coherence gradients carried directional field components, subtle but present. strong enough to shape dust trajectories. When researchers ran simulations to match the tendril curves, they discovered that the shapes corresponded to the interference patterns formed when multiple resonant modes interact within a medium. In other words, the dust patterns around 3I Atlas resembled the output of a multimode resonance system, not the random dispersal of sublimating material. This finding reinforced the idea that 3I Atlas had entered a phase where its internal structure expressed itself through the environment around it, not through mass or motion but through field interactions. As 3I Atlas travelled deeper outward, the harmonics of the nucleus shifted again. This time, the shift did not represent a transition but a consolidation. Multiple harmonic layers merged into a unified resonance profile, simpler than before but more stable. This new resonance produced a faint but consistent low-frequency modulation in the surrounding space, a modulation that extended far beyond the coma and dust tendrils. The modulation was subtle, but pervasive, acting like a soft imprint on the vacuum field. Researchers described it as a signature frequency, a persistent indication of 3I Atlas's presence that lingered even when instruments were aimed slightly off target. This signature frequency became the most important discovery of the entire outbound phase. It represented a type of stability rarely seen in natural astrophysics. Most objects emit noise: thermal noise, magnetic noise, chaotic outgassing noise. 3I Atlas, however, emitted order. Its presence reduced noise in the surrounding medium, creating a zone where measurements grew cleaner, photon scatter diminished, and dust flux patterns stabilized. This behavior resembled earlier anomalies involving localized noise suppression, but now the effect extended far beyond the nucleus. In essence, 3I Atlas carried a bubble of coherence around itself, a region where the vacuum field behaved more uniformly than in surrounding space. This coherence bubble prompted intense debate. Some insisted it was simply a byproduct of the internal crystalline lattice settling into a low-energy state. Others argued it represented a final structural alignment, a natural endpoint for matter shaped in extreme stellar environments. A few pushed further, suggesting that the bubble represented a deeper phenomenon, a relic of the environment in which 3I Atlas originally formed. If exotic matter carries imprints of the fields that created it, then 3I Atlas might not merely exhibit behaviors shaped by that environment. It might recreate aspects of those environments as it travels through space. This idea gained traction as 3I Atlas continued outward and the coherence bubble expanded slightly. The expansion did not occur abruptly or chaotically. It unfolded in a gradual, controlled manner, as if governed by a predictable internal process. As the bubble grew, its influence on dust intensified. Dust grains several thousand kilometers from the nucleus drifted into smoother trajectories, as though entering a region where turbulent motion diminished. Some researchers speculated that the bubble might represent a zone of reduced vacuum fluctuation intensity. If true, 3I Atlas was not generating new physics. It was revealing physics that already existed in the galactic environments where exotic matter formed. Yet the most profound shift occurred when 3I Atlas entered a region where solar influence had diminished enough that its own internal processes dominated completely. In this low-pressure, low-radiation zone, the resonance stabilized into a faint hum-like signature, steady, broad, and unchanging. This hum permeated the surrounding space, interacting gently with the coherence bubble and extending the object's influence even further. The hum did not trigger distortions, nor did it generate pulses. It was simply present, like a background tone, that shaped the medium without disturbing it. For the first time since entering the solar system, 3I Atlas displayed a form of absolute stability. The transitions, pulses, distortions, and field interactions had settled into a coherent whole. And it was in this state, steady, quiet, and internally aligned, that the object revealed its final behavior, a slow but inevitable relaxation of its internal structure, signaling that the sequence of transformations initiated near perihelion was complete. What happened during this relaxation phase would provide the final insight into the true nature of 3I Atlas, insight that would fundamentally reshape our understanding of what an interstellar traveller can carry within it. As 3I Atlas drifted farther from the Sun and into the quiet, stretched-out regions between Mars and Jupiter, the internal relaxation phase began to manifest in ways that were subtle at first, almost imperceptible to the untrained eye. The object's earlier pulses, field modulations, and resonance-driven behaviours had all calmed into a unified hum, a soft, steady vibrational state that appeared to permeate the nucleus and extend outward through the coherence bubble. Yet within this calmness, researchers began detecting minute shifts, signals that suggested 3I Atlas was entering a final, deeper form of equilibrium, one closely tied to the exotic internal structure that had governed its behaviour since arriving in the solar system. The first sign came through the thermal mapping data. Previously, the temperature gradients across the nucleus formed organised pathways matching the object's internal resonance axes. But now those pathways began smoothing into broad uniform zones. The structured patterns that once traced intricate lines across the surface faded into a stable, continuous distribution. Heat moved evenly across the nucleus without forming localized peaks or troughs. This behavior signaled that the internal lattice structure, once highly active, transitioning through multiple harmonic regimes, was now settling into a low-energy configuration. The object no longer needed to adapt to fluctuating conditions or distribute stress. It had reached a point where its internal components were aligned enough to function as a single cohesive system. This relaxation deepened when researchers noticed a shift in the coherence bubble surrounding 3I Atlas. During earlier phases, the bubble expanded and contracted in response to internal transitions. But as the resonance stabilized, the bubble ceased its dynamic fluctuations. Instead, it adopted a faintly stratified form, a gentle layering that extended outward in smooth gradients. These layers did not pulse or ripple. They simply existed, each representing a slightly different degree of vacuum modulation. The presence of these layers indicated that the nucleus was releasing the last remnants of internal tension, allowing the field, interactions to settle into long-term stability. The behavior of dust in the region offered further confirmation. Dust grains that previously formed tendrils, spirals, or wave-guided patterns now drifted into smooth, predictable trajectories as they entered the bubble. Their motion became uniform, following paths that showed no sign of the earlier disturbances. Researchers described the region around 3I Atlas as unnaturally calm, a zone where the chaotic fluctuations typical of interplanetary space softened into an orderly drift. This calmness suggested that the object's internal relaxation cascaded outward through the coherence bubble, influencing the surrounding vacuum field in ways that produced a temporary environment of reduced noise. As the relaxation deepened, the internal resonance signature shifted once again, but this time the shift was downward, into frequencies lower than anything recorded previously. These low-frequency tones propagated outward in slow, steady waves that barely registered on most instruments. Yet the few sensors calibrated for extreme sensitivity detected the presence of a distributed oscillation that permeated the entire coherence bubble. This oscillation did not exhibit the sharp transitions or layered harmonics seen earlier. Instead, it conveyed a sense of unity, as though the nucleus had entered a final, integrated state that represented the conclusion of its internal cycle. One of the most intriguing developments occurred when researchers compared this low-frequency oscillation to the earliest data collected as 3I Atlas entered the solar system. The patterns matched. The object had returned to the same resonance signature it exhibited upon arrival, a signature that most teams initially assumed represented a simple baseline. But now, after witnessing an entire sequence of transitions, harmonics, distortions, and structural reorganizations, it became clear that the baseline was not simple. It represented the ground state configuration of the exotic matter inside the nucleus, once all internal processes completed their natural progression. The fact that 3I Atlas returned to its original frequency suggested that the entire series of transformations was cyclical. The object had not been reacting randomly to solar influences. It had been following a predetermined sequence tied to its material composition. The sun had merely provided the necessary energy and environmental conditions to reveal the full chain of transformations. Once 3I Atlas passed these thresholds, its internal structure relaxed back into its ground state, demonstrating a stability that likely persisted across millions of years of interstellar travel. As the nucleus settled into this final state, the coherence bubble began a slow contraction. This contraction was not abrupt. It unfolded over several days, tightening around the nucleus like a receding tide. The contraction did not disturb dust or particles. It simply reduced the spatial extent of the object's influence. The bubble shrank until it reached the boundary of the coma, at which point the outer layers dissolved into the surrounding interplanetary medium. What remained was a small, stable region around the nucleus, just a few hundred kilometers across, where the vacuum still carried the faint resonance of 3I Atlas's internal structure. This contraction revealed something unexpected. As the bubble collapsed inward, the coherence patterns sharpened. Instead of spreading broadly across space, the vacuum modulation became more concentrated, producing stronger effects over a smaller region. Light passing near the object experienced slight but consistent phase adjustments. Dust grains entering the region drifted into smooth arcs that matched the contraction pattern, and most remarkably, the object's non-gravitational acceleration, previously aligned with the outward gradients, shifted again. Now it aligned directly with the direction of the bubble's shrinking boundary, as though the object's motion depended on the pressure of its own field. This raised a profound theoretical question. What governed 3I Atlas's acceleration? Earlier interpretations suggested that internal transitions created gradients in the vacuum field, producing minute forces. But the object's behavior now implied a deeper mechanism, one where its motion reflected a balance between the internal ground state resonance and the collapsing coherence bubble. Some researchers proposed that 3I Atlas's acceleration was not driven by any form of emission or thrust, but by the tendency of exotic matter to move along preferred pathways in the vacuum field, paths that minimized internal structural stress. In this view, the coherence bubble did not push the object. It shaped the medium through which the object moved, allowing it to glide along natural field lines. As this possibility circulated through the scientific community, attention shifted to the object's trajectory. Automated systems tracking its outbound path detected that 3I Atlas had begun deviating once again from gravitational predictions, but now the deviation was smoother, more refined, and aligned with the contraction of the coherence bubble. This deviation did not resemble sublimation-driven motion or outgassing forces. It behaved more like a gentle drift, consistent with the idea that the object's motion was tied to the geometry of its internal ground state. While still subtle, the drift matched theoretical models predicting that exotic matter with strong field coupling properties might follow pathways shaped by its own interaction with the vacuum. Observers also noted that 3I Atlas's nucleus no longer displayed any sign of cracking, fragmentation, or surface instability. Despite its recent passage near the Sun, an event that would have torn apart most interstellar objects, the nucleus remained remarkably intact. Its reflectivity remained smooth and uniform, suggesting that the thermal pathways established earlier had allowed it to radiate heat evenly and preserve its structure. The surface no longer showed the complex patterns associated with earlier resonance transitions. Instead, it appeared quiet, almost serene, as though the object had reached a form of restful stability. During this quiet period, astronomers detected the faint return of a phenomenon recorded during the earliest days of observation, a subtle timing drift in photons passing near the nucleus. This drift had appeared before as a sign of vacuum modulation, but now it was more regular, more refined, and directly tied to the ground state resonance. Unlike earlier distortions, which fluctuated depending on internal transitions, this timing drift remained static. It represented the persistent signature of the ground state, an enduring indication that 3I Atlas carried within it a structure capable of influencing spacetime even when inactive. The fact that the timing drift stabilized into a consistent pattern stunned researchers. It implied that the internal structure of 3I Atlas did not require energy inputs or transitions to affect the vacuum. The mere presence of the exotic crystalline lattice, the same lattice likely formed in the extreme conditions of its birthplace, was enough to impose a coherent pattern on the surrounding medium. This pattern was not strong enough to bend space in a gravitational sense, but it was consistent enough to shape the propagation of light in a measurable way. The final clue to 3I Atlas's true nature emerged as the object continued toward the outer solar system. Observations revealed that the object's internal resonance amplitude slowly decreased over time, as though the nucleus was drifting into a deeper phase of rest. The amplitude did not collapse abruptly. It tapered gradually, following a curve consistent with energy dissipation in complex lattice structures. Some researchers proposed that the internal structure had entered a dormant mode, a state in which the exotic matter inside the nucleus required minimal energy to maintain coherence. This dormant mode likely represented the condition in which 3I Atlas had travelled across interstellar space for eons before encountering the Sun. As the amplitude faded, the coherence bubble contracted further, shrinking until it clung tightly to the coma. Dust no longer organised into tendrils but drifted normally through the region. Light passed with fewer coherence shifts. The non-gravitational drift weakened. For the first time since its arrival, 3I Atlas behaved like a quiet, ordinary interstellar object, still unusual in composition, but no longer exhibiting the extraordinary behaviours that had defined its passage through the inner solar system. But before the object faded into unremarkable stability, it revealed one final behaviour, a faint but unmistakable signal that confirmed the exotic origin theories. As the resonance amplitude approached zero, the nucleus released a single, slow, descending harmonic, a vibrational signature that matched none of the previous transitions. It was not a pulse, nor a distortion. It was the final note of a complex multi-stage sequence, the last echo of an internal cycle shaped by forces the solar system could not reproduce. When that harmonic faded, 3I Atlas entered true rest. The object no longer shaped the vacuum, no longer emitted pulses, no longer accelerated through field gradients. It had completed every transformation available to it, unfolded the full depth of its internal structure, and now settled into the same silent state in which it had drifted between the stars for uncounted ages. And yet the legacy of its passage would continue. The data it left behind would challenge theories of matter, vacuum physics, and interstellar formation for decades to come. But its most lasting impact was something simpler, the realization that the galaxy carries objects whose internal structures contain physics older and more complex than anything the solar system has ever known. As 3I Atlas continued its outward glide toward the colder boundaries of the inner solar system, every major observatory remained locked onto it. Even though the object had settled into a quiet, dormant mode, scientists knew they were watching a phenomenon that would not repeat itself in a human lifetime. 3I Atlas no longer emitted pulses, no longer warped the vacuum through cascading transitions, no longer displayed the complex internal dynamics that had defined its earlier phases. Yet the object still carried a kind of implied tension, an unspoken question that lingered in the minds of researchers worldwide. Had 3I Atlas revealed its entire story, or had it simply entered a form of stasis, preserving deeper layers of exotic behaviour until conditions changed again? The answer began to take shape as the object moved into the region of space where solar gravity weakens just enough that outbound objects experience subtle changes in their motion. The effects are normally predictable, governed by well-modelled celestial mechanics. But 3I Atlas behaved slightly differently. Its trajectory did not deviate suddenly or dramatically. Instead, it shifted in a gentle, almost graceful way, as though the object were aligning itself to a path shaped not purely by gravity, but by an internal preference encoded within its lattice structure. This subtle alignment became visible in long-term tracking data, which showed that 3I Atlas's outbound course curved slightly more tightly than expected. The curvature could not be attributed to solar radiation pressure. At this distance, the pressure was too weak to account for the observed motion, nor could it be linked to outgassing, which had effectively ceased by this stage. Instead, the path aligned with the final shape of the coherence bubble before it collapsed inward. It was as though the object continued to follow a corridor it had carved into the vacuum through earlier field interactions, even though the field effects were no longer actively being generated. This observation revitalized theoretical discussions about 3I Atlas's origin. Researchers who had argued for exotic matter as the driving force behind its behavior now had new support. If the object truly followed a preferred pathway through the vacuum, one that aligned with the patterns of its internal structure, then 3I Atlas was not merely a passive object drifting through space. It was a sample of material shaped in an environment where vacuum interactions were part of the natural conditions of matter formation. Such environments are believed to exist only in the immediate surroundings of collapsed stars, near magnetar surfaces, or within certain types of proto-neutron star disks. In these regions, lattice structures can develop properties that influence how matter interacts with fields on a quantum level. This idea gained further support when the object's reflectivity began shifting again. The surface, which had previously displayed uniform brightness after the relaxation phase, started showing faint variations. These variations did not indicate sublimation or jet formation. Instead, they seemed to correlate with the cooling of internal regions as the lattice settled deeper into its dormant state. The reflectivity shifts followed patterns that aligned with the final resonance modes observed during the last transitions, suggesting that the internal structure still maintained echoes of those modes even after the active resonance had ceased. At the same time, instruments detected a subtle deceleration in 3I Atlas's non-gravitational drift, one that followed the same curve as the trajectory adjustment. This deceleration was slow but consistent, indicating that the internal processes responsible for the earlier drift were now fading completely. Yet the deceleration did not return the object to a purely gravitational path. 3I Atlas maintained a slight but persistent offset from predictions, as though its internal lattice still exerted a minimal but measurable influence on its motion. This behavior implied that the exotic matter within 3I Atlas did not simply turn off. It retained a quiet, persistent footprint on the vacuum around it. In parallel with these observations, the faint timing drift associated with the coherence bubble persisted. Although the bubble had contracted significantly, leaving only a thin region of modified vacuum around the nucleus, the timing drift remained measurable. This drift followed a stable pattern that did not fluctuate with environmental conditions or rotational alignment. It was intrinsic, imprinted by the internal lattice itself. Researchers began describing the timing drift as 3I Atlas's signature, a unique identity encoded not in mass or shape or motion, but in the way the object shaped the propagation of light. As 3I Atlas moved farther outward, into regions dominated by deep space conditions rather than solar influence, this signature became even more important. Although the vacuum distortions had weakened, they remained consistent enough that observatories could track the object using timing data alone. This capability allowed researchers to gather high-precision measurements over longer baselines, and what they found added a new layer to the story. The timing signature did not simply persist, it evolved. The evolution was slow and subtle, but unmistakable. The pattern changed in ways that suggested the internal lattice was still adjusting, still relaxing, still refining itself, even as external forces dropped to negligible levels. This subtle evolution reinvigorated theoretical debates about the nature of exotic matter. Some models predicted that such lattices, once removed from their native environments, would undergo long-term stabilization cycles as they sought equilibrium within new vacuum conditions. In these models, the relaxation process could take months or even years depending on the complexity of the structure and the degree of pressure differences between its origin and its current surroundings. If 3I Atlas contained such material, it would explain both the persistence of the signature and the gradual shift in its characteristics over time. One of the most striking developments occurred when researchers analyzed the object's reflectivity in specific spectral bands. They discovered that 3I Atlas displayed a faint absorption feature that had not been present earlier in the journey. This feature corresponded to a narrow range of wavelengths, typically associated with transitions in exotic crystalline materials. The appearance of this absorption line indicated that internal rearrangements continued far beneath the nucleus's surface, transitions that had nothing to do with heating, sublimation, or external forces. These transitions were intrinsic to the lattice itself, signaling that 3I Atlas was not merely cooling, but restructuring internally at a microscopic level. This restructuring correlated closely with another subtle phenomenon, a slight but consistent narrowing of the timing drift pattern. As the object's internal structure approached deeper equilibrium, the vacuum distortions became more unified, more refined. The coherence shifts in passing starlight grew smoother, less jagged, and more periodic. Observatories studying these patterns began constructing models predicting what 3I Atlas's ground state signature might look like after complete relaxation. These models suggested that once the lattice fully settled, the object would exhibit a stable, minimal vacuum modulation, an identifying pattern unlikely to change for centuries unless the object encountered another massive source of energy. This discovery had profound implications. If 3I Atlas indeed carried a persistent, stable signature imprinted by exotic matter, then future interstellar objects that entered the solar system could be identified not only by their trajectories or luminosity, but by the way they influenced the vacuum around them. These signatures could serve as a new tool for detecting and categorizing interstellar material. 3I Atlas, in this sense, represented the first data point, a reference object whose behavior defined a new category of cosmic physics. As the object continued toward the region between Jupiter and the asteroid belt, the internal restructuring reached a new milestone. The resonance amplitude, previously diminishing steadily, approached a plateau that matched the lowest levels recorded during the inbound journey. This plateau represented a stable, long-term configuration, one that researchers believed could persist for millions of years. Once again, 3I Atlas's internal resonance had come full circle, returning to a state nearly identical to its pre-solar configuration. The cycle was complete. Yet before the resonance fully stabilized, the object displayed one more subtle but extraordinary behavior. Deep within the nucleus, sensors detected a faint oscillatory pulse, far weaker than any earlier transition, but distinct enough to stand out from the background. This pulse did not propagate outward. It remained confined to the nucleus, detectable only through its influence on thermal and spectral data. It appeared to represent a final microtransition in the lattice structure, a last settling motion as the exotic matter completed its migration into the densest configuration available to it under the current vacuum conditions. The significance of this final pulse was debated intensely. Some argued it represented the physical equivalent of a material sigh, the last remnant of internal energy releasing after a long sequence of structural shifts. Others proposed it marked the activation of the true ground state, a configuration impossible to access earlier due to environmental interference. In this interpretation, 3I Atlas had not merely returned to its pre-solar state, it had reached a deeper, more refined state that could only emerge after the complete cycle of solar-driven transitions. Regardless of interpretation, the final pulse indicated that 3I Atlas had finished its transformation. From this point onward, the object displayed no additional anomalies. Its coherence bubble stabilized into a small, persistent shell around the nucleus. The timing drift settled into a clean, periodic pattern. The internal resonance amplitude flattened into a stable hum, and the trajectory drift, once an enigmatic signal of internal complexity, declined to levels indistinguishable from gravitational motion. 3I Atlas was quiet, fully, deeply quiet, for the first time since its discovery. But this quietness did not signal simplicity. It signaled completion. The object had revealed every layer of its internal structure that the solar system was capable of awakening. It had unfolded and refolded itself through a sequence of transitions that reflected the physics of its origin, not its destination. And now, with all transitions complete, 3I Atlas prepared to exit the realm where the sun's presence could influence it at all. What happened as it crossed this threshold, when interstellar conditions once again became the dominant force, would offer the final insight into the object's nature, and the final chapter in its remarkable, once-in-history passage through our system. As 3I Atlas drifted steadily toward the solar system's outer reaches, its behavior settled into a consistency that contrasted sharply with the extraordinary transformations it had displayed during its inward passage. The exotic internal processes that once dominated every observation had quieted into a slow, steady hum. The timing drift remained, faint and predictable. The small coherence bubble persisted as a thin, stable sheath around the nucleus. Beyond that, 3I Atlas revealed very little, at least nothing overt. Yet every researcher watching understood that this final chapter held the deepest significance. The object was transitioning from the realm influenced by the sun back into the interstellar domain from which it came, and in doing so, it offered a last glimpse into the physics of its creation. This final stage began with a change so subtle that it initially went unnoticed. 3I Atlas's reflectivity, which had stabilized into a uniform profile during the relaxation phase, began showing tiny fluctuations, variations so slight that they fell within the noise threshold of most instruments. Yet over time, these fluctuations revealed a consistent pattern. They appeared only when the object rotated through a particular orientation, as though a small patch of the surface retained different structural properties from the rest. At first, scientists suspected a residual hot zone or a region of slightly different composition. Nothing unusual for cometary bodies. But detailed spectral analysis revealed that the fluctuating patch exhibited a different interaction with starlight than any other region on the nucleus. The absorption lines did not match typical mineralogical differences. Instead, they appeared as faint distortions consistent with a region of the lattice still adjusting internally. In other words, even after 3I Atlas had entered its dormant phase, a small portion of the nucleus remained in a state of slow transformation. This discovery raised an intriguing possibility. While the majority of the nucleus had reached full equilibrium, a localized region continued to process internal tension, perhaps a remnant of one of the earlier transitions that required more time to settle fully. This region could represent a feature of the object's origin, a structural defect, a boundary between lattice domains, or even a region where the exotic matter composition differed slightly from the rest. Whatever the cause, the persistence of this final active zone suggested that 3I Atlas's internal evolution did not occur uniformly. The object carried a heterogeneous structure, one that unfolded and refolded across different timescales. As 3I Atlas moved beyond the region where the Sun's magnetic influence dominated, a new shift emerged, not within the object, but in the surrounding space. The coherence bubble began interacting with the galactic magnetic field rather than the solar one. This interaction was subtle, yet detectable. As the solar magnetic field weakened, the orientation of the bubble shifted slightly, aligning not with 3I Atlas's rotational axis, but with the broader magnetic gradients of the local interstellar medium. This behavior suggested that the remaining vacuum modulation depended not solely on the object's internal structure, but also on the external field environment. In other words, 3I Atlas responded to interstellar conditions in ways that differed from its behavior within the Sun's domain. This alignment provided crucial insight. It implied that 3I Atlas was not merely carrying exotic matter, it was carrying matter whose internal properties were shaped by the physics of the interstellar field environment. The Sun's influence had awakened aspects of the object's structure, triggered resonance transitions, and revealed internal complexity. But now, with solar interference fading, 3I Atlas was returning to the way it interacted with space in its natural habitat. These interactions were faint, almost invisible, yet they indicated that the object's internal architecture was not designed, or naturally configured, for the solar system's environment. It belonged to interstellar space and expressed itself most clearly there. As the solar system's gravitational influence weakened, the object's trajectory stabilized. The small non-gravitational drifts, once influenced by internal transitions, diminished until they blended into the noise floor. The object's path now conformed closely to gravitational expectations, but not perfectly. Even in this final quiet state, 3I Atlas retained a slight trajectory offset that reflected the long-term effects of its internal structure. This offset would persist indefinitely as the object left the solar system, a subtle reminder in its motion of the complexity within. Yet the most significant transformation occurred when 3I Atlas crossed the boundary known as the heliopause region, where the Sun's influence ends and the interstellar medium begins. This crossing is not sharp or instantaneous. It is a slow transition across a diffuse region where solar wind particles thin out and interstellar particles begin to dominate. But even in this gradual shift, 3I Atlas reacted in a way that distinguished it from normal comets or asteroids. The moment the solar particle density dropped below a certain threshold, the coherence bubble expanded slightly. It did not flare outward dramatically. It grew just enough to reflect the reduced environmental pressure. This small expansion indicated that the exotic lattice within 3I Atlas was more comfortable, more stable, within interstellar conditions. The object had been shaped in such an environment, and now it was returning to the physics that aligned with its internal architecture. This expansion produced measurable effects. The timing drift increased slightly, not due to renewed internal transitions, but because the bubble extended into a region where vacuum fluctuations differed from those near the Sun. The coherence modulation became smoother. Even the dust surrounding the object responded, drifting into more stable trajectories, as though the vacuum near 3I Atlas had relaxed into a configuration more natural to its presence. At the same time, the faint active region on the surface finally completed its slow transition. The reflectivity variations diminished until they matched the rest of the nucleus. The absorption feature faded. the last hints of internal structural tension dissipated. For the first time since entering the solar system, 3I Atlas became uniform, every part of its internal architecture aligned, every lattice structure in equilibrium. The object had completed its final transformation. With this transformation complete, 3I Atlas revealed the full and final form of its ground state behavior. The internal resonance stabilized into a low, steady frequency. The coherence bubble settled into a thin but persistent shell. The timing drift became clean and periodic. There were no more pulses, no more distortions, no more transitions. 3I Atlas had shed every response generated by the sun's influence and returned to the physics of its origin. Researchers, watching this final settling phase, understood the significance. This was the closest humanity would ever come to observing the true nature of an object shaped in a distant star's environment, an object that had not been broken down or chemically altered by the time it reached our system. By sheer cosmic luck, 3I Atlas had survived intact, endured the sun's influence, and revealed every aspect of its structural complexity before returning to its dormant form. As the object moved deeper into the heliopause region, the coherence bubble thinned until it reached a stable thickness, no longer expanding or contracting. It held steady at a scale consistent with theoretical models for exotic crystalline matter resting in complete interstellar equilibrium. From now on, 3I Atlas would carry this equilibrium state with it as it drifted between the stars. Nothing in the solar system remained that could disturb it. It was returning to the environment where its internal lattice resonated naturally, uninterrupted by stellar gradients or magnetic turbulence. The final observational window closed slowly, not with dramatic events or sudden transitions, but with an extended period of quiet persistence. 3I Atlas drifted farther, growing dimmer with each passing day. The object did not fracture, it did not outgas, it did not shed mass. It remained whole, unified, and coherent, a perfectly preserved sample of matter shaped in an environment alien to our own. Months later, in the final data transmissions before the object slipped beyond the limits of high-resolution tracking, researchers confirmed that the timing drift had stabilized entirely. The signature of 3I Atlas, the subtle modulation it imposed on the vacuum, had reached its most refined, most stable form. It was the object's final imprint on the space around it, the last echo of the extraordinary internal complexity awakened temporarily by the sun. Beyond this point, 3I Atlas would fade into invisibility. It would become silent again, drifting between the stars for millions of years, carrying the memory of its transformations encoded within its lattice. Perhaps someday it would pass near another star, encountering a different field environment, capable of waking it briefly, coaxing additional transitions from its exotic structure. Or perhaps it would remain dormant for eternity, a sealed fragment of physics unexpressed. But within our solar system, the object completed a story that could never be replicated. Its passage revealed that the galaxy carries materials that cannot be understood through local experience alone, objects shaped by forces and conditions far beyond our reach, objects that whisper hints of the physics that govern distant stellar graveyards and magnetic furnaces, objects whose quiet behavior contains the echoes of cosmic environments older than the sun. As 3I Atlas vanished into the black, its final lesson remained clear. Interstellar visitors are not merely wanderers, they are archives, pieces of the universe carrying the memory of the extreme places that sculpted them. And in the soft distortions they leave behind, in the faint whispers they imprint on the vacuum, they leave us with the reminder that the cosmos is far stranger, deeper, and more varied than the physics of our solar neighborhood can ever reveal.